Most HTML tutorials are doing it backwards. They start with the tags, they show you the p tag, div tag, h1, hand you a list, and tell you what each one does, which feels productive until you close the tutorial and realize you can't actually reason about any of it. You can copy, but you can't think. Here's the thing. HTML wasn't invented in a vacuum. It was invented to solve a very specific problem. And the moment you understand that problem and watch HTML get derived as the answer to that problem, every tag starts to make sense. You stop memorizing, you start understanding, and even predicting. You see a tag you've never seen before, and you can guess what it probably does. And you're usually right. That's what this video does. We're going to invent HTML before we use it. Then we'll write it with a Google document on one side and a code editor on the other. As crazy as it sounds, you'll watch every button you already know, bold, italic headings, turn into the HTML tag that creates it on your web page. Then we learn about technologies that make the web work, like DNS, HTTP, IP, URLs, all these weird terms and buzzwords, and we boil them down to their core to understand simply how they work and what they do, to the point that it will be hard not to understand them. And now, let's go and learn HTML. To invent HTML, we have to start somewhere strange. We're not going to look at HTML yet. We're not even going to look at a computer. We're going to start in the 80s, as a book publisher drowning in papers. Stay with me. The problem they had is the exact same problem HTML was invented to solve. Once you see that, you will never look at a tag the same way again. Imagine you're a book publisher. Every day, writers send you their manuscript so that you can publish them. But there is a problem. Some writers write by hand on paper, others use Microsoft Word, some organize their work in clear chapters, while others send you one massive chunk of text with no structure. As a publisher, you're drowning in chaos. How do you efficiently process all these different formats? How do you find the book title, the author name, or even know where one chapter ends and another begins? This is exactly the problem that existed on the early web, and it's the problem that HTML was designed to solve. Let's continue with our publishing analogy. To make your publishing business scalable, you need to establish a standard. You can't keep dealing with the overhead of different formats and styles and personal preferences that different writers use. So you create a structure, a format for book data that's easy for you to work with and process, easy for writers to adopt, and intuitive for them to learn. You create a manual for them to understand this format as well, and maybe even a software to test their submission and catch errors before sending them to you. Now your business becomes scalable. You expect book data to arrive in a specific format, and writers can do whatever they want during their creative process. But if they want to publish through you, they must translate their work into your expected format. The key insight here is labeled data. Instead of receiving a paragraph like this, where you have to read through everything to find basic information, you want something simpler. A label and a value. Like this. Label, value. That's the entire idea. You get exactly what you need, nothing more, nothing less. The data format is predictable. Now, in our publishing system, this label value format ends up looking like this. We'll get into exactly why the designers of this format decided to make it look like this. For now, just notice the shape. The label wraps around the value. Let's take a closer look. We call these, with angle brackets, tags. They look like this. Let me break this down. The book name is our label, and this is the start tag. That one is the end tag. Notice the extra forward slash. That's how we know it's an end tag and not a start tag. The value, programming 101, goes between the start tag and the end tag. The generic format looks like this. Very good. Now that we have established a predictable way to represent our data, we define specific tags we expect the writers to use in their book data. We have defined 3 tags, 3 labels, book name, author, and content, and we expect every writer to have these informations filled for the books that they want to publish. Next, we create a manual for our writers with clear examples and explanations for each tag. We don't expect our writers to know these informations by heart. That's why we write documentation. Here's how our documentation looks like. It's called Writer's Manual BTML Guide. And BTML stands for Book Text Markup Language. So it's a language to mark up text of books so that we know which part is which. We have 3 required tags. We have defined each of them, the format we expect, the purpose, and the rules that the writers must follow, along with some concrete examples. So they need to write their book data in this format and follow the rules if they want us to publish their books. Take a look at here. We are telling the writers that we have already created a validation tool, a software, so that they can validate their book data before sending it to us. We don't expect everyone to have the time to read all of our documentation, so we have designed a validation software to help them with validating their books. That's just common sense. This is exactly what happens on the web. Web browsers are like our publishing business, and web developers are like writers. Before HTML, there was no standard way to structure web content. HTML stands for Hypertext Markup Language, became that universal standard. In HTML, instead of book name, we have other tags like title and P, which stands for paragraph. But the idea is the same. This standardization is why any browser can display any website and why any developer can create contents that works on all different browsers. The web became scalable because everyone agreed to use the same structure. Just like our publishing business, browsers can efficiently process content because they know exactly what format to expect. By now, we have a working format. Writers submit structured data, and publisher processes it reliably. The chaos is mostly gone. But here's the thing. Once you actually start using a system like this, you run into new problems. Problems you couldn't predict until real data started coming in. Our structured format has been working great, and writers are successfully submitting their new books using our 3 tags. Here's an example. We had the book name, author, and content, and this writer has published his book, Rise of the King, from John Smith, and this is an example of the content. But after working with this system for a while, I'm getting feedback and noticing some issues that I want to improve. Here are some of the author tags that I'm seeing among different writers' submission. As a publisher, I need to separate first names from last names for my own record. This is my business requirement. But look at this mess. Some have middle names, some don't. Some have titles, some use initials. I'm spending way too much time figuring out which part is the first name and which part is the last name. There has to be a better way to do this. Here's my solution. Instead of one generic author tag, I want to be more explicit. I want to capture different subparts of that information separately. The old way was that I had an author tag, and the writer would put every information related to the author inside that tag. In the new way, I have the same author tag, but I want explicit subparts inside of it. Title, first name, middle name, last name. These are the subparts explicitly defined for the author tag. Notice what's happening here. The author tag now contains 4 other tags inside it. In nesting, we have a parent-child relationship. The author tag is the parent, And the title, first name, middle name, and last name are its children's, are its subparts, if you will. All the child tags are related to their parent. That's why they are inside that parent tag. They belong inside their parent. With this approach, each piece of information is now explicit and labeled. No guesswork. Very good. Let's go and change our BTML format. So from now on, writers must write their author tag in this new format. But wait, I can't just change the format overnight. I have existing customers and users who are already using the old format. If I suddenly change the rules and stop accepting the previous format, I'll frustrate them and potentially lose their business. It's not fair to them and it's not beneficial to me. I need a way to support both the old format and the new format while giving my existing customers time to transition, time to adopt the new format. This is where versioning comes in. So I will create format versions, just like software has version numbers. Each book data will declare which version of my format it's using. This way I know if it's following the new standard or the old standard. So I'll add a special tag at the very beginning of every document. It looks like this. It has an exclamation mark to show that this is a special tag, and what's inside it is that its document type is of version 1. This tells me which version of my format rules this document follows. Now my processing system can look at this first line and know exactly which rules to apply and which tags to look for when reading the rest of the document. Here's how a book document looks like in the new version versus the old version of our format. Beautiful. Now I get exactly the information I need in a structured, predictable way. The authors can either use the new version or the old version to send their information over. But now I need to encourage the writers to adopt the new version. Here's my business strategy. I'll continue to accept the old format without the doc type for the existing customers, but I'll encourage everyone to migrate to version 1.0. Maybe I give the existing customers a grace period of 3 months, and after that, I will require them to adopt the new version. This way, nobody gets frustrated, but I gradually improve the quality of data I receive. Eventually, I can phase out support for the old format once the grace period has elapsed. What did we learn? First, tags can contain other tags. This is called nesting. It makes logical sense to group related information together. Here's an example. We have street, city, and zip code. All of these informations are childs, are subparts of the address. And here's how we capture them in a structured format. Secondly, we have learned about versioning. Versioning is how a system evolves without punishing the people who are already using it. In the real web, HTML has evolved through many versions, using the same DOCTYPE tag and versioning concept. This is how web maintains backward compatibility, while still improving over time. Very good. Our format is solid, but a new type of customer is showing up. Books written by multiple authors together. And our format has no way to handle that. I'm getting new requests from customers that are pushing the boundaries of our current system. Here's what's happening. I have new customers who write books together. They want to publish a single book with multiple authors. They're asking me to improve my format to handle multiple authors. Here's an example of my current format. The problem is obvious. My current format only supports one author per book. Here's my proposal. I need to change my format to allow for a list of authors to be inserted. With the current format, I can capture the information for each individual authors using the existing author tag that I already have. But I need another tag to hold these multiple author tags together. So I create an authors tag, notice the plural form, that will contain my list of the individual authors, like this. Perfect. The authors tag is the parent tag. It's like a container, and each individual author tag is a child item inside that container. This creates a clear parent-child relationship where the container, the parent tag, in this case authors, holds multiple similar items, the child tags. In this case, it's author, singular. Now a book can have as many authors as it wants. What if a book has 5 authors? Then put 5 author tags inside. What if it has only 1 author? Then just put 1 author tag inside. This introduces us to an important pattern for handling lists in structured data. In this pattern, we have a container tag, usually named using a plural noun, like authors, which holds multiple item tags, usually named singular, like author. Let me show you another example. What if I want to track the chapters of a book? Then I can have a tag named chapters, and inside that I can have individual chapters as separate tags. The chapters container holds multiple chapter items. Sounds logical, isn't it? Very good. Our format is getting more powerful day by day. But now I'm facing another challenge. I'm receiving books written in different languages: French, Persian, Spanish, and more. I need to know what language each book is written in so I can process them correctly. Here's an example. I could try to read a few lines of the content and guess the language, but remember, the whole point of structured data is to eliminate the guesswork and make everything predictable. But notice this, the language information is special. It's not part of the book's content, but it's information about the content. It's metadata that helps me, the publisher, to understand and process the book correctly. This is where attributes come in. Attributes give us extra information about a tag without adding anything to its actual content. Here's an example. Look at the opening tag carefully. After the label, which here is content, I add a space and then write the attribute. The attribute name is language, and then I say equal to quotation marks, and inside the quotation marks, I put the attribute value, which in this case is English. It is telling me that the language is English for the information that this tag is capturing. Remember, attributes are always written in the opening tag, never in the closing tag. Let me show you a few more examples of how attributes work. I have a content tag with language attribute equal to French, and it is telling me that this tag is capturing some content that are written in French language. Next one is another content tag, this time with language set as Persian, and then we have a book name tag with a language set as Spanish. So no matter the tag, the attribute gives us extra information about that tag. Notice that attributes don't change the content itself. They just provide additional information about it. The Persian text is still Persian text, but now I know it's Persian without having to guess between Persian and Arabic. Well done! Here's an example of our enhanced format with both lists and attributes. Notice that I bumped up the version to 2.0 since we have added new capabilities. Let's recap. What have we learned? 2 powerful concepts. First, we learned lists, which use a container item pattern. And second, we learned attributes, which provide metadata about a tag. So far, we have a format that handles multiple authors and accepts some metadata about some tags. But as our format grows, a new problem is starting to emerge: organization. All our tags are sitting side by side with no logical grouping. And that's going to become a problem fast as we add more and more capabilities to our format. As my business grows, I want to include more information in BTML document, like contact details, publishing dates, ISBN number, copyright information, and more. If I just keep adding these tags side by side, my format will soon become a chaotic mess. Think about organizing a file cabinet. You don't just throw everything into one drawer. You create sections, Important documents go in one section, correspondence in another, financial records in the third, and so on. I need the same logical organization in my book format. When I'm looking for publisher contact information, I shouldn't have to search through the entire document. That's annoying and inefficient. See how unorganized this is? If I want to look for an information, I should start reading each tag line by line until I find the relevant information. There is no logical grouping. Here's my solution. I will create structural tags that organize related information together. These tags are purely for organization and making the format easier to navigate. Here's what I propose. Notice three important things. First, I created a book container, a book tag, that holds everything. This is a root element that says this entire document represents a book. Second, I have a metadata section for all the information about the book, like title, authors, publisher details, and so on. Third, I have a content section for the actual book text. Chapters, paragraphs, the stuff readers will see. All goes here. Let me show you an example of how this works in practice. I have organized the same information, now with some extra structural tags. Now, if I want to look for the contact information of the publisher, I know that I need to look into the metadata tag because it's information about the book. In here, I have a publisher tag, and in that, I have the contact email. This time, I knew that there's a logical place for this kind of information to be found in my document. Beautiful. Now I have logical sections that make the document easy to navigate and understand. This structural approach gives me several advantages. First is easy navigation. As we have seen, I was able to find the publisher contact information by looking in the metadata section. Second benefit is processing efficiency. My publishing system can quickly extract just the metadata for cataloging or just the content for printing. Third benefit is clear separation and scalability. I can now add new metadata tags without cluttering the content area and vice versa. And this is exactly how HTML works. HTML uses structural elements to organize page content. The head section contains metadata about the web page, like title and author, just like our metadata section. The body section contains the actual visible content, like heading, paragraphs, images, just like our content section. Let's wrap up. Take a look at our journey so far. We have started with this simple problem. A publisher who needs to receive book data from different authors. We learned that the structured data solves the scalability problem. We discovered nesting, lists, attributes, and finally, structural organization. Every web page you visit uses these exact concepts. HTML is just a more detailed version of the book format we built together. The next time you see HTML, remember, it's solving the same fundamental problem, bringing order to chaos by making data structured, predictable, and well organized. We want to turn the table around. We are going to be the writers of the book. We are going to be web developers who want to publish their content, their website, on the web. The web already has a standard, and it's called HTML, Hypertext Markup Language. Our job is to learn this format, use it to capture our web content, and then publish our website on the web. So, before we learn the new format, HTML, let's see how much of it you already know. Let's go and take a look at the real HTML document and dive right in. Here's our first HTML document. It should be under section 2 in your starter files. Through this button, I'm going to run it side by side. This is how the website is going to look like based on the content I've written here. For now, we don't need that. Let's close it. And I have also included an example BTML format. That's the format we have created in the previous lesson. Let me select HTML as the language format so that the tags are colored like this. And then I'm going to put these two files side by side. I want you to take a minute or two and go over these two documents side by side and compare different tags that you see here. Before we go over together, I want you to notice that how many of the concepts that we have learned in the BTML format directly translates to the HTML. So take your time and come back after a minute or two. On the first line, we have doctype HTML that refers to which version of the HTML standard this document is going to use. And this HTML means this document is going to follow HTML5. On the other side, we have the doctype 2.0. That means this document, this BTML document, is going to follow our second version. Same idea. Then we have an HTML tag, I can collapse it if I want, that captures everything else that is inside my document. This is the root element, the most outer element, and it is suggesting that this document is an HTML document. On the other side, I have my book tag. It was my root element, and it suggested that this document is capturing a book. Here on the book element, I have an attribute. The label is language, its value is English, and it is providing extra information about the book itself, that its language is English. On the HTML side, I have the same thing. Here, instead of language, I have lang, and for the value, I have en for English. Then, inside the HTML tag, I have two main tags, which are the head and the body. Under the book, I have the same structure. I have one section for metadata and another section for the content of the book. So the content is the actual content that the readers will see, and metadata is information about that content. Here we have the same idea. Body holds the actual web contents of your web page that your user sees, and the head section that captures the metadata about your web page. Under the head section, we have some other tags. Let me open the metadata as well. Here we have the book name that describes the name of the book. Here on the other side, we have title that describes the title of the web page. It's the same idea. Take a look here. We have a meta tag with an attribute name that is set to author, and the content is my name, Kian. On the other side, we have a different structure. We have authors tag. Inside it, we have author tags. That's a list. And then here I have the same information. Captured, this is my first name and this is my last name. In section 1, since we were the designers of this format, we've decided to represent the author information like this. The HTML designers, on the other hand, decided to have this element and these two attributes to describe who is the author of this web page. It's the same information captured in two different formats. Let's take a look at the body. We see there are more information in this page that are captured using different set of tags that you may or may not have heard of. So not everything in HTML format is going to be familiar to you, and that is okay. Do you still remember our Blender mindset? Someone has created a tool. In this case, it's HTML. When we were designing the BTML format, we have created a documentation for the people who wanted to use our format. We didn't expect everyone to just know what decisions we have made when designing this format. Same is true with HTML. HTML has documentation to document what sorts of decisions the designers has made about representing different piece of information. No one expects you to memorize all the details related to HTML language. You should have a conceptual understanding of what sorts of problem this language is trying to solve, and then use documentation as you need to find out the details. Let's go take a quick look at it. Here on the example 1, if you scroll down, you should see an element like this. We have an OL element, we don't know what that means, and then inside that we have a few other elements which are LIs. If you remember, this is the list pattern that we have talked about. We have a parent element, and inside that we have a series of similar elements. Let's go open the MDN docs and take a look at the documentation for this tag. Here I'm on MDN, go under the HTML tab, and here you have all the documentation related to HTML language. You have some guides and how-tos, and there are some references for elements, attributes, and other things. Under the filter, let's filter them out and look for the OL tag. Here under elements, here's the OL. We see that the OL tag represents an ordered list of items. We have an example here that is showing us live. We can make change and take a look at the output. Under the attributes, these are the valid attributes that you can put on this element to change its behavior. For example, if you add the reversed, then the list is going to be shown in the reversed order. Let's actually use it. I'm just going to copy it and paste it here as an attribute. And you can see that the numbers are now starting from 5 and going up to 1. So these are just some extra attributes that make sense on this OL element. Then we have the usage notes and some more examples about this element. We have an example about nested list. We're going to get to this in the future lessons. That's an example of it. And finally, we have a table about technical summary, which holds some technical information that you probably have no idea about right now. Specification, we're going to get to that shortly, and browser compatibility. These three will make sense once I told you the story behind HTML and how the web works. And that's going to happen by the end of this section. That was MDN, one very good example of HTML documentation. We're going to talk about that more in the future lessons. Remember, in BTML, we have decided that writers cannot memorize all the rules, so we have designed a validator, a tool that writers can validate their BTML format before submitting it to us. And HTML has the same tool. It's called HTML Validator. You can put your HTML there. It's going to validate it based on the rules, and it's going to tell you whether it's a valid HTML or not. So just search for HTML Validator. The first link should be the one. Here under the HTML validation, let me go to the not detailed page. Under the direct input, I can just copy paste all of the code that I have in my example, paste it here, and click on check. And you see that there is no error in this document, and this is a valid HTML document. But for example, if I remove the head section of this HTML document, so I just have a body section, I remove the head and click on check, I see that I have an error. Then I can go and check the documentation and figure out why this element is necessary. If you click on this link here, it's going to open the documentation, but on a website that we haven't learned about. This website on top is what we're going to learn in the future lessons. And we're going to understand why this exists beside another site, which is MDN. Why we have two documentation websites for HTML. We're going to talk about that. So we had a quick tour and exposure to HTML and the tools and documentations around it. And now let's talk about what this section is going to be about. The HTML tags that format the web content fall into two general categories. One is the textual tags, the tags that capture the textual data that you see on the web, and the non-textual tags, the tags that represent non-textual data, like images, videos, audios, and things like that. In this section, we're going to focus on the textual web content and the HTML tags that is going to capture those textual contents. Pay attention that HTML is not inventing textual content. It is providing a format, a structure to capture the textual content. And I'm pretty sure you already have experience working with textual content. Probably you have wrote a letter, a report, a document, or other sorts of things. So tell me, what tools have you used so far for writing and editing textual content on your computer? Probably a word processor, like Microsoft Word, Google Docs, LibreOffice, or something else. Let me open Google Docs, and I will tell you why we are even mentioning that in this course. Here's Google Doc. It's a free software. You just need a Google account to use it. So if you don't have a Google account, create one and open Google Docs. We're going to use that a lot in this section. And here's why. HTML is not reinventing text. It's giving a structured format to capture that textual information. If HTML is as good as it claims, then it should have relevant tags to capture any textual information that Google Docs can represent. So that's how we're going to learn textual content. We're going to open a Google Doc, put it side by side. We're going to write something, make it look a certain way, and then represent the same information, this time using HTML tags, and learn along the way. That's where we're heading to. So let's get started. Here's our setup. I have an index.html file. It's an empty HTML file. And on the right, I've opened a blank document on Google Docs. So to get started, I need the boilerplate code related to HTML. For that, I can use this VS Code feature. I can just type an exclamation mark through this meant abbreviation. I can just select that, and the boilerplate HTML is going to be created for me. The boilerplate HTML are the minimum required tags that any HTML page need to have. So the HTML tag, we have the head and the body tag, the title, and some metadata tag that we will learn about later. For now, you don't need to care about it. All you need to know is that you need to type this exclamation mark to get the boilerplate tags. We're going to write everything we're going to learn inside the body tag. All right, let's get started. Here on Google Docs, if I just start typing, for example, hello world, I'm going to get a paragraph. This is just a paragraph of text that is going to be created for me. To create the same on the HTML, I need to use the right tag. And the tag for paragraph is called p tag. So I create a p tag, and inside that, between the start tag and the end tag, I'm going to put the content, which is hello world. Let me put it, and let's preview that. This is how the website is going to look like, just a paragraph. Nothing special so far. If I want to add another paragraph here, I will just press enter, go to the next line, and then I can type something else. On the HTML side of things, if I want another paragraph, I need to create another p tag and put the new content inside. So I will have two p tags, one after the other. Here's how it's going to look like. I have two paragraphs. In Google Docs, I have hierarchy of textual content. So this is just a text, that's why it's labeled as normal text, but I can have headings here as well. If you go to the format menu, under the paragraphs, you can see we have headings from 1 to 6. Let me create one from each and show you how they look like. This is different levels of heading that Google Docs has to offer. It starts from heading level 1 and it goes all the way to heading level 6. Heading 1 is the highest in the textual hierarchy and heading 6 is the lowest. HTML has the exact same concept. It has headings from 1 to 6 and the tag names are H1 through H6. Let me create them all here on the left. Let's take a look at how they look like. Here you can see the same hierarchy. It starts from the biggest most heading, that's the heading level 1, and it goes all the way to the smallest heading, which is heading level 6. The intuition is that HTML did not invent different levels of heading hierarchy. They already existed. HTML just created a format to capture that information using tags this time, instead of going to a menu and clicking on a button. So we have seen the tags that we have for paragraphs and different heading levels. Now we're going to talk about text formatting, and we're going to play a little game together. Let's get going. In Google Docs, if I want to make this piece of text bold, I just need to select it and then press on this button to make the text appear bold. And that's how I make the text bold. Now my question to you is, what do you think I should do to make that text appear bold in HTML? Let me put it here. What tag do you think I should use to make the text appear bold? Let's try to read the mind of the HTML designers. So I have the p tag for paragraphs, and I have h1 tag for heading level 1. Clearly, HTML designers liked short abbreviation, p instead of paragraph, for the tag name. Now my question to you is, what tag corresponds for making the text bold? What name do you think HTML designers have chosen for that tag? Probably you're guessing B, because they liked short phrases, and probably they chose the first letter of the word bold. Let's go check it out. Here I have that HTML text. Currently it looks as normal text. Let me create a B tag and put it around it. Well, you see that using B tag, I was able to make the text appear bold. That's interesting. So short logical tag names looks like the way to go. Let's continue. If I have B tag for bold, then what tag you think I should have for italic? Is itag a thing? Let's go check it out. Here in Google Docs, if I want to make this text to look italic, I need to find the button, which is this one, and by pressing it, the text is now italic. Here, on the HTML side of things, if I want to turn this text to italic, let's take a look to see if the I tag is a thing. And surprise, that's exactly the tag that we need. What if I want this piece of text to look italic and bold? On Google Docs, I will apply both styles to it, On the HTML side, I need to wrap it in 2 tags, both of them at the same time. Let me do it. Very well, now that text looks bold and italic on my website. Let's see if this pattern of tags continue to appear. Let's continue and learn more tags. If B tag is for bold and I tag is for italic, then what tag is for underline? Well, I believe you're guessing that it should be U, and you'll be right. We're going to see that in a second. Now what about a strike through? What tag should we have for the strike through format? And you're probably guessing S, and you'll be right again. Let's go see it. On Google Docs side of things, if I want to make the text underline, I will choose this button. On the HTML side of things, for the underline, I have the U tag, as we guessed it. Let's take a look. There we go. Now that text is underlined. And for the strike through, well, the button is not here. If you click on the format and go to the text, you see the strike through here. Let's apply it. The text is a strike through. And for the HTML, we guessed that we should probably have a tag called S for the strike, the first letter of the word strike through. And we're right. Believe it or not, you are reading the HTML designer's mind. You've discovered the pattern of thought that they had when they designed HTML tags. And now based on that, you can guess how tags are named for different purposes. Let's take it up a notch. Here I want to write 4 to the power of 2, so I need to select 2, go on the format, and apply the superscript. And for this one, this is H2O, the chemical formula for water, and that 2 need to be the subscript of the H. Let's go to the format, text, and apply the subscript. Now, what tags do you think I should apply to the 2's here to make one superscript and the other subscript? Let's think about it. So we have U for underline, S for strike through. Now we're asking what tag should correspond to subscript. Clearly, it's not going to be S, because S is already used for the strike through, and it's not going to be the whole word subscript, because clearly the designers of HTML didn't like long words. Probably, a designer with these characteristics would have picked just enough letters to differentiate subscript from its counterpart, which is superscript. And for that, you need the first 3 letters, the sub and sup, and that's why probably the tag names are sub for subscript and sup for superscript. Let's go try that. Here for 2, I need to make it superscript, and we see that's exactly the case. The tag name is sup. And for 2 here, I need to make it subscript, and you see that one is exactly true too. So the guy liked short phrases, and the shortest phrase that he could possibly have was to have the first 3 letters to differentiate them from each other. So you are thinking like HTML creators now. You understand the problem that they were trying to solve, creating different tags to capture different contents, and you've seen the pattern in their design. Now you can make educated guess on what kind of tags exist to capture different sorts of content. But pay attention that you're understanding the reason behind their decisions. You're not becoming a fortune teller or a psychic. Here's an example of when predicting doesn't work. Here on Google Docs, if I want to highlight this text, I can use this button and pick a color, for example, yellowish, and then this text is going to be highlighted. What tag do you think corresponds to highlighting text on HTML? So we have S for strike through, sub and sup for superscript and subscript, and now what do we have for highlighted? Maybe you're thinking H or high or something like that, and no, the answer is mark for highlighted, because the designers were thinking of the word marked instead of highlighted. That's why they chose mark for the tag name. Here's the text that I want to mark. If you try to find something with highlight or anything like that, you will find that there is no auto-completion. So that means there is no such a tag as this. But for mark, we see that we have that tag. So this auto-completion is going to help you to understand whether the tag you're using is the right one or not. So now the text highlighted yellow. This difference of taste in choosing the right word for expressing the same idea is exactly why we have documentation. You cannot possibly predict and understand every design decision that someone makes. That's why you need documentation to understand their reasoning. Let me search for it. Of course, you can use AI, and AI is going to use the documentation, or you can directly go to the documentation and find the mark tag that is going to be used for highlighting texts. So the pattern helps most of the time. When it doesn't, you have the documentation to help you out and bring you back in line. Now let me show you something about white spaces. In Google Docs, I have two paragraphs. First paragraph, second paragraph. I have the same in HTML. In Google Docs, I can just press enter in between paragraphs to add extra empty space in between them. But in HTML, if I add the same amount of space here, that space is not going to appear inside my web page. Here's the idea. The HTML ignores the extra white spaces you add in between elements. And it has a good reason for that. HTML documents are all about tags, and tags are the only thing that HTML understands. So if you add extra white spaces in between tags, you still have the same number of tags. It doesn't make any difference. If you want to add extra white spaces between your contents, you need to do it in a way that HTML language understands, and that is through tags. For adding line breaks, new lines between your content, we can use the BR tag, which stands for break. And we need to capture that information that we want, line breaks, using the correct tags. BR tag is a special kind of tag. It is a standalone tag. Here's what it means. HTML tags have this structure. We have the label that is inside the opening tag and closing tag, and the value goes in between. For example, for the paragraph, we have the P stands for paragraph in the opening tag and closing tag, that's our label, and the paragraph content goes between them. Now for the BR tag that captures a line break, this structure doesn't really work, because what kind of content are we planning to put inside a BR tag? Well, nothing, because BR tag is not capturing any content. It means we need a line break. Therefore, we really don't need the content area and the closing tag. Only the opening tag will suffice. So if a tag's job is to represent something, like a line break, then we really don't have any content to put inside this tag. The tag itself represents something. Therefore, those tags are standalone tags. They don't have a closing tag or the area to put the content inside them. It's just the opening tag. And you can write them in either way. You can just write the opening tag, or you can write the opening tag with a trailing slash. Both works the same way. Let's go take a look. Here in between my paragraphs, if I want to add extra blank lines, I can create the BR tag. BR stands for break. Now I have a new line captured in my web page as well. I can add more if I want more new lines to be captured. Also, if I want to add extra spaces inside elements, like inside p tag between these two words, if I just add spaces like this, it is not going to work as well. That the space is not going to be captured in my web page. So just one space between each word is going to be captured. If I want to add extra spaces, I need to capture that using tags. It is going to work the same way with the new lines. If I add new lines between words, it's not going to show up here. If I want to add those new lines, I need to do that by using the right tags. Here, for example, I used the BR tag and added the new line between those two words. So all the extra white spaces that we are going to add in our HTML are going to be ignored in our web page. There is a practice called minifying HTML files, and it is all about removing all the empty spaces between your elements. Let me show you. Just search for minify HTML, go to this website, copy paste all your HTML content, and you see the minified version here. All of the spaces have been removed in between elements, but the content is preserved. Let me copy it and paste it over here. I need to save my document without prettier formatting it back to this. That's why you can press Command-Shift-P and then search for save without formatting so that the initial content is preserved, and you can see your web page doesn't look different at all. So all the extra spaces that you add in between your elements are going to be ignored. You are adding them just for your convenience so that you can read an HTML document easier. Let's learn one more tag and practice what we have learned so far through this tag. In Google Docs, I can add a horizontal line by going to the insert and clicking on the horizontal line. A horizontal line is going to be added here. Now my question to you, for capturing a horizontal line on HTML, can I do that by just typing this? Your answer should be no. And the reason? which is more important, is that HTML only understands tags. So if I want to capture a horizontal line, I need to do it through the right tag. So we have sub for superscript, BR for line break, and that is a standalone tag. It doesn't have a closing tag. Now what tag you think we have for horizontal line? If you want, you can consult with documentation and then continue. We have the HR tag for creating horizontal line. My question to you is, do you think this tag is a standalone tag or not? And the answer is yes. HR represents a horizontal line, and we don't have any content to put inside it. That's why it makes sense for it to be a standalone tag, and it actually is. So here in between my paragraphs, if I want to create a horizontal line, I need to create that using the HR tag, and here's that horizontal line captured for me. And pay attention that HR is a standalone tag. You can write it like this, or you can add a trailing slash if you like. Both works the same way. Let's recap. We have learned quite a few tags in this lesson and realized the pattern that HTML designers have used in choosing the tag names. Before ending this lesson, I would like to show you something and leave you with a question. We have learned to make this text bold, I need to wrap it in B tag, just like this. Let me show you this one. It's a tag called strong. That also made the text look bold. So we have B tag for making the text bold, and we also have a strong tag for making the text bold. Why would the people who designed HTML created two tags for the same purpose? My question to you was, why the HTML designers have designed two different tags for the same purpose? Before I answer that question, I need to show you something first. Here's a Google document that I have prepared, and it is about FAQ, frequently asked questions, about the product named CloudKeep. It is a very simple document. CloudKeep FAQ is the main title. That's why it's heading level 1. Then I have multiple sections. I have getting started section, as it's shown here. I have accounts and billing, security and privacy, and so on. Each of these sections are heading level 2. Inside them, I have questions as heading level 3, and the answers are normal text. So these are just paragraphs. That is the hierarchy and the structure of this document. So this is a simple and organized document. As you can see, Google Doc is applying some styles to different type of text that I have so that I can see the hierarchy of the document more clear. Now, what do you think will happen if I remove all the styles from the document and make all of the text look the same? Make all of the text look like this paragraph. Let me actually do it. Now all the text that I have on this document look exactly the same as normal text. So I don't see any visual difference between headings and paragraphs. Here's my question to you. Does that mean that this document that I have here no longer has structure or organization? Do I no longer have text hierarchy? Take a look at the panel on the left. Even though everything in my document looks exactly the same, I can still see the structure here. See that this is the main title. Then I have different sections. And inside each section, I have those questions clearly defined. So I can move to a specific question using this outline on the left. So even though I have cleared all the styles from my document, the meaning is still there. This text that you see here is still the heading level 1 of my document. And here's the insight. Being heading level 1 on a Google Doc means something. It means this is the main topic of this whole document. So it means something to be the heading level 1 of a document. That heading level 1 also has some styles. For example, it has a bigger font size, bolder text, and so on. But if you remove the style from heading 1, the meaning will not go away. Meaning and style are two separate things. Removing one does not remove the other. In our example, we have removed the style, but the meaning was still there. HTML works exactly the same way. HTML tags are about capturing the meaning of the content and not the style. Let's go see the FAQ document, this time written in HTML. Here's the same FAQ document. It is available under section 2 files. And you can see that the structure is clearly captured here. We have the heading level 1, heading level 2s for each section, and then for questions, heading level 3, and the text is paragraph, as it is shown here. Let me do the same and remove all the styles that is currently applied on our HTML tags. I need to do that using CSS. Don't worry about it, we're going to learn CSS later. So create a style tag inside the head section, and in here type body space star. That means select everything that is inside the body element. So I'm going to select all the elements that are inside the body, then curly brackets, and select all and set it to unset. So I'm unsetting all the styles that are on every element inside body. And as you can see, every style that was set on those elements is now gone. So using CSS, I have removed all the styles, and now every piece of text looks identical to each other. So the style is removed, but the meaning is still there. And that meaning is captured using the HTML tags. The CloudKeep FAQ is still the heading level 1 of this web page. So HTML is about capturing the meaning of the content, regardless of its style. And CSS, which we're going to learn later on, is about capturing the style of our content, regardless of its meaning. So it means something for a piece of text to be the heading level 1 of our document, and we're capturing that information using HTML. Let me remove this style reset rule. Maybe you're asking, but we haven't wrote any style for our different HTML elements. Where does this style that is applied here coming from? And here's the answer. These coming from the default style that the browser applies to your HTML tags. Take a look at Google Docs as an example. In Google Docs, when you select a piece of text and make it heading 1, a default style is going to be applied to that text. And that is going to help you to differentiate it from other piece of text that is on the web page. Like for example, from a heading level 2. This is the default style. Let me reset this style to the default. So by default, Google Docs applies a style to different type of text that you have so that you can see the hierarchy of your document easier. Same thing exists with HTML. The browser has default styles that it's going to apply to your different HTML tags. We will learn about that later in CSS. So in conclusion, HTML tags capture different pieces of our content based on its meaning and regardless of its style. Then, for styling any element, we have CSS, and we use that language to style the elements regardless of their meaning. So we have two separate languages for two separate concerns, meaning and style. Now let's get back to the question that we have started this lesson with. Why do we have B tag and a strong tag to make the text bold? The answer is really interesting, that this is not the right question to ask. HTML is not about styles at all. It is about meaning, about the semantics of our content. The HTML tags carry a meaning regardless of what style we apply to them. So let me fix the question and ask the right one. Why do we have B tag and a strong tag, and what meanings do they capture? And here's the answer. The strong tag captures that this piece of content is important. The bold appearance is just the browser's default style for showing the importance. But when you're writing HTML, the meaning is the only thing that matters. This element is called a semantic element. That means this element captures a meaning about its content. Now let's see the B tag. The B tag, on the other hand, does not capture any meaning. We use it for the content that we later on would like to style bold, but that does not mean that piece of content is important. So the default style for the B tag on the browser is bold appearance as well. And this element is called a generic element. This element does not capture any extra meaning. That's why it's generic. Let me make this idea concrete through some examples. Here's our example file. Imagine you're creating a website for a pharmaceutical company. And this is an example of a content that we would like to structure using HTML. Please read this paragraph and tell me which sentences or words are important, and we probably want our users to notice and read them. I would say the third sentence. Do not take more than one tablet in a 24-hour period. The reason is, if our user ignores this text, something can go wrong. And to capture the importance of this piece of text, I'm going to wrap it inside a strong tag. Here we go. Now, next question. Which word or sentence is not more important, but we want to make it stand out because it's a brand or company name? RX Clear, our brand name. It is not important for our users to notice this, but because this is our brand name, we want it to stand out. That's why we wrap it in a B tag. So B tag is a generic tag. It's not semantic. It is not capturing any extra meaning, but it represents that we want this content to stand out and appear bold. Very good. Next question is even more important. Let me make it ready. Imagine you're using this tablet for medication. If I remove the strong tag around this instruction, can you still understand and realize that this instruction is important by reading through it? The answer is yes. For you, as someone using this medication, this instruction is important in itself. The importance is within the content. And that is exactly the point. The strong tag does not create importance for the content. It captures the importance that is already there in the content itself. So tags do not add meaning to their content. Tags capture the meaning that is already there in the content itself. So you cannot put a not important text in a strong tag and suddenly make it important. That's not how it works. HTML does not create meaning for your content, it just captures the meaning that already exists in your content. I hope you realize the difference. And finally, last question. If a text is important, should we always style it bold? And the answer is no. Depending on the context, we may like to make the important content to look bold and red, to show warning and danger, or maybe we want it to be italic and yellow, to just be a warning, or maybe we just want it to be a large, all caps letters. So we can decide to style our content however we want later on using CSS, and that's why we have the separation of concerns. We have HTML that has only one concern, to capture the meaning and structure of our content. And we have CSS that has a separate concern, to capture the style of our content. So we have two separate concerns and two different languages to deal with them. When we are writing HTML, we are only concerned with capturing the structure and meaning of our content, and style is irrelevant to us. Later on, when we're writing CSS, we will only care about the style of our content, and the meaning will be irrelevant to us. We talked about HTML and its role in capturing the meaning of our content. We saw one example involving two tags. We have a B tag that captures no meaning, and we have the strong tag that captures the importance of the content. That's the meaning it captures. The B tag is a generic tag because it does not capture any meaning, and the strong tag is a semantic tag because it carries the meaning of its content. We saw that both of them, by default, are styled as bold, and we learned that the style is an irrelevant concern when we are writing HTML. The style is CSS concern, a language that we're going to learn later. Here's what I want you to notice. This was not a special case. This is a pattern in HTML, and you see it almost everywhere. Let me show you the same pattern using a different pair of tags. In the previous lessons, we saw the I tag, which by default made its content italic. And the I tag is a generic tag because it does not capture any meaning. Then we have the EM tag, which stands for emphasis, and the meaning it captures is that the content inside this tag needs to be emphasized. We'll see an example of that shortly. So this is an example of a semantic tag because it carries the meaning. And the style of this content, by default, is italic as well. So we see the same pattern, this time using two different tags. Let me show you an example in the browser. Here I have this sentence which reads as, "Get out of my room now." But sentences can convey a different meaning if a specific word is stressed. Let me show you this example. I have added the word now inside the EM element, which stands for emphasis. And now let me read this sentence again. Get out of my room now. This sentence is now more assertive and conveys a different tone and meaning to the reader. The default style for emphasized word is italicized. Maybe you're thinking, how would the readers know that if a word is italicized, they need to emphasize it? That's a good question. Probably they don't know and they wouldn't emphasize. But you're not writing HTML just for the readers of your website. You're writing HTML for different machines and technologies that are going to use and read your website to your users. For example, we have text-to-speech technology that will read the content of the web page to your users. And that technology will read this sentence differently to your users if it sees that some words needs to be emphasized. Here's another example. The term bandwidth describes the measure of how much information can pass through a data connection in a given amount of time. Here, because we're defining the term bandwidth, and probably for the first time, and that is a technical word, we want it to stand out from other piece of text that's around it. That's why we may decide to make this word italicized, to signal that this is a technical term. Let me do that. And now the term bandwidth is italicized. But through the I tag, we're not capturing any extra meaning relating to this term. We just want it to look a little bit different from the text around it. So the pattern is that HTML almost always gives you two versions. A generic version of a tag that doesn't capture any meaning, and a semantic version that has a specific meaning and purpose. For example, we have the I tag for italicizing the text. It doesn't capture any meaning. And we have the EM tag, stands for emphasis, and that has a meaning and purpose. Both of them has the default style of being italic. Another example is that the B tag, which didn't capture any meaning, and the strong tag, which captures the importance. Both of them has a default style of being bold. Let's see more example of this pattern by learning another group of HTML elements, which are structural elements. The elements that we use for grouping the content in a web page. This is an example web page from W3 School. What I want you to notice is that a web page will have different areas and different regions where different type of content will appear. You already know this concept when you're writing Word documents. Let me show you. Here's an empty document on Google Docs. In Google Document, mainly you have three areas. One is the area where you write the content. This is the main area of your document. Then you have the header area. This is a special area. You add different sorts of information here, maybe a logo or your name. Then we have the footer area where you add different type of information, maybe copyright information or page number. So you have meaningful regions in a document, and each region will capture the relevant information for that region. Let's see another example. Here's another Google Docs. This time it is a newsletter. And you can see we have a smaller column on the right side of the page. This region is called an aside column. This is where you put the information that are complementary to the main information on your page. So this region is usually used for side notes and complementary information. And last example, we have a book. And the first thing that you see in a book is table of content. This is the area where you can use to navigate to different chapters of a book. Here, for example, I can see where chapter 3 starts, and then I can go to the page which corresponds to that chapter. So I'm using this area for navigating to different part of the book. The exact idea applies when you're looking at a web page. On the top bar, we have the header section. And as you can see, the logo is found there. In the center part, we have the main region that captures the main content that this web page is talking about. At the bottom, we have the footer area, just like our Google Docs. Here on the left side, we have a navigation area. We can use these different links to navigate to different contents available on this website. And on the right, we have the side column, where it holds the complementary information. Let me zoom in to the main section. Here in the main section, we can have a smaller group of things. For example, this, which is a section. It starts with a heading describing what this section is about, and then the relevant information will follow after that. So our web page, just like our Word document, has a specific regions that are used for specific purposes. And for these regions, we have the structural tags that group the relevant content that appear in those areas. And these are semantic elements because they have a meaning. They give an identity to the contents that they hold within them. These are the semantic grouping elements. And as you've seen our pattern so far, we have generic grouping elements as well. Let's take a look at that next. Take a look at this area of the website. Here we have 6 logos for social media, and that's the HTML code corresponding to them. We will learn image tag later, so don't worry about it. Now, for styling or technical reasons, we may want to group all these logos together, like this. Through doing that, we will be able to apply a certain style to their container and affect the look of all the elements within it. Our reason for grouping these elements is non-semantic, and that's why we will use a div tag. Div stands for division, is a generic tag that is used for grouping elements together. A div element does not capture any meaning or give any identity to the items that it captures. So we use that when we want to group some items together for a non-semantic reason, maybe for styling. So let's take a look at our web page so far. We have defined grouping elements to capture different parts of our web page. A bad practice that I've seen in the wild is to use div elements to capture all the regions of your web page. This is a bad practice. Now your web page does not have any meaningful regions. Just a reminder again that you're not writing your HTML just for your users to read. There are other technologies that your end users use in order to interact with your web page, and those technologies rely on you to structure your HTML properly. For example, a screen reader who wants to read to your user what this web page is about, it is going to go straight to the main content and read from there. But if you have all generic elements on your web page, then it has no idea which region it needs to read first, because now you don't have any meaningful grouping. Let me talk about one more idea before concluding this section, and that is the idea of inline versus block elements. And the idea is very simple. Let me show you. Inline versus block is about how the elements behave when you put them one after the other. Here, for example, I have 2 paragraph elements. I put them one after the other, and now each of them will occupy a whole line. So this element will occupy this line altogether, and the next element will start from the next line and do the same thing. This is how an element behaves when it is a block element. Now let's take a look at the inline element. Here I have 2 b tags, one after the other, and you see that both of the tags will appear together one after the other on the same line. That's why they're called inline element. They appear in the same line and they don't create a new line for themselves. This concept is not at all an HTML concept. This is a CSS concept. Let me show you. I create a style tag in the head, and here I'm going to add a rule, selecting the p element, and I'm going to set their display to be inline. Now, as you can see, the p tag's behavior has been modified to now behave like the inline elements. But the idea is that HTML designers have decided to make some elements to be by default block element and some element to be by default inline element. And that's why we have these 2 categories. Some HTML elements are block elements by default, and some HTML elements are inline elements by default. Let's take a look at another example. Can you tell me whether the div element is block element or inline element? Well, all you need to do is to put 2 of them together and see if they will appear on the same line or on 2 different lines. Here we see that the div, each of them appear on its own line. That's why it's a block element. So div element is a generic tag that it is used for grouping items together. And by default, its style is block. That means it takes the whole line. The HTML designers have created a different tag called span tag, and that tag is also a generic element that captures no meaning, But the difference is that this time it is an inline element by default, and it is used to capture a piece of content within a line. So that's their only difference. One of them is block display by default, and another one is inline display by default. Both of them are generic, and they're used for the same purpose. Here's div element and span element side by side. We see that the div elements are block level elements, that's why each of them appear on its own line, and the span element are inline elements. That's why they're appearing in line together. Let me show you an example of where the span might be useful. Here we have this sentence, the word bonjour means hello in French. Did you realize how I read this sentence? I didn't read the word bonjour means hello in French. I didn't read this text as English word. I read it as French word. And I want to capture that information here, that this word is French, so that the text-to-speech technologies will read this word as a French text and not as English. And to do that, I wrap it in a span element because I want this text to appear in line, and then I will capture that information as an attribute. So lang need to be French. Now I have captured that information in this sentence using a span element that doesn't add any extra meaning to this text, but now it's capturing that this text is written in French language. What happens if I use a div element instead of this span? Let me show you. If I use a div element, because div appears on its own line, it's a block element, then my sentence is going to look like this. And that is not what I want. So it's better for me to use a better tag that by default has a more consistent style to the end results that I want to have. Therefore, I use a span element. So this is the question that you need to ask yourself when you're writing HTML, whether you need a semantic element or a generic element for your content. And your job is to use semantic element when the meaning is there in the content, and use generic element otherwise. For example, if you need to group some elements that are related to navigating to different parts of your website, then you need to use a nav element for that grouping, a semantic element. On the other hand, if that grouping doesn't have any extra meaning and it is for technical or styling reasons, then you need to use the generic grouping element, which is just a div. If a piece of content has extra importance, you need to capture that using the strong tag. But if you just want that piece of content to stand out without having extra importance, then you use the generic counterpart, which is the B tag. This idea will become more concrete as we learn more and more HTML elements to represent our content. Let's learn about HTML elements for capturing lists. First of all, what is a list? Well, a list is a collection of related items. A list has a meaning, and it's important to separate that from its style. Let me show you what I mean. Imagine you want to bake a cake. Here's a bulleted list of ingredients. This is clearly a list. What if you remove the bullet points? Is that a list also? What if you write them on one line and separate them with a comma? Is that a list? To you who wants to make the cake, all of this works the same way. You need a list for the ingredients, and it really doesn't matter how to style that list. That list has a meaning. It's a collection of related items. These are the items you need to bake the cake. Now, whether you use bullet points or not, this is styling concern, not the meaning concern. It is this meaning part that we want to capture using HTML. We have three types of lists in HTML. Let's learn the first one, the unordered list. Here we have our ingredient list again. We have 5 items there, and the second item is eggs. Take a look at these two variants of the list. I have moved eggs around to be the last and first item in that list. Now to you who wants to bake the cake, does this order matter? Will you make a different cake if I move the egg to be in different position in the list? And the answer is no. The position is irrelevant. That's why it is an unordered list. So in this type of list, the order of items is meaningless. Here's how we capture the unordered list in HTML. Let's take a closer look. I have the UL element, which stands for unordered list. It is an unordered collection of related items. Here the order of items is meaningless, and its default style is to put bullet points before each item. Then inside that element, we have each item captured as an LI. LI stands for list item, and that element captures a list item. Let's take a look at that in the browser. We are taking a look at an unordered list that I've shown you in the previous slide, and here is how it's rendered on your website. As we have discussed, a list is capturing a meaning that the items that are inside are a collection of related items. All of them are ingredients to baking a cake in this case. And the bullet point is just a styling concern. Let me actually remove that bullet point. So I create a style tag inside head. I select the UL element, and I will set the list style type to be none. And now those bullet points are gone. But the meaning that these 5 are part of the list is still there and captured using the HTML UL element. The second type of list that we want to learn is ordered list. And this one is an ordered collection of related items. Let's take a look. Now that I have the ingredients for baking the cake, let's see the recipe steps. Here are the 4 steps, and I have highlighted the second one, which is about adding the eggs. Now tell me, if I change the position of this step and move it to the last, will you make the same cake? Does the order matter? And the answer is yes. These 2 lists are not equal anymore. That's why we represent an ordered list using a sequence. Here we're using a sequence of numbers. We can use a sequence of letters. Doesn't matter, as long as we capture the order of the list. And again, this is an ordered list not because we added the sequence before it, but because if you change the order, the meaning will be different. So the order is part of the meaning that we would like to convey. Here's how we capture that list in HTML. Let's take a closer look. We have an OL element, OL standing for ordered list, and it is capturing an ordered collection of relevant items. Here, the order is meaningful. And the default style for OL is that its items are numbered. Then inside that OL, we have the same LI elements, which represented a list item. Here we have those recipe steps. Each of them is a list item, and they are captured inside an OL element, an ordered list. And they are rendered on our web page using a list that is numbered from 1 to 4. As we have mentioned, that number is a styling concern. And if I want, I can remove that number. Let me do that quickly. Same as before, I created a style tag, selected the OL, and set the list style type to none. Now those numbers are gone, but the meaning that the order of these steps are important is captured using this semantic element, the ordered list. The last type of list that we have is a definition list, where we have some terms and some description of those terms that we would like to capture. An example of this will be a glossary section at the end of a book, where you have different terms along with their definition. Let's see how we capture that in HTML. Here's an example of a definition list. I have some terms, HTML, CSS, and HTTP. These are my terms. And I have some definition for each term. Here are the tags that I need to use. I need to use a DL tag. DL stands for definition list. It captures a list of items with term and description structure. Inside the DL tag, we have 2 types of tag. We have the DT tag, the definition term, which wraps the term that we want to define, and by default, its style is bold. And we have the definition description, the DD tag, which holds the description for that term. And the order matters here. First, we have the term, and then the description for that term, and then another term with the description for it, so on and so forth. Let's take a look at this in the browser. Here's a description list. I have the DL tag, which wraps the whole list, and then I have each term captured using a DT, a description term, and its definition coming right after it using a DD tag. DD stands for definition description. I also have updated our cake page and added a glossary at the end. Here, the terms that are used in the recipe steps, for example, sift, is defined using a description list at the end of the page. And the same structure for description list has been followed here. As a review, I have wrapped the terms inside an I tag. Because it's a technical term, and I want it to look a little bit different from the text that comes nearby. And that was one of the use cases of the I tag. Before we close this lesson, let's take a look at MDN documentation for unordered list. I want to show you how to create sublists. Here's an example. A sublist is a list that is inside another list. Here we have two items in this list. The first one is milk and the second one is cheese. But the cheese item has a sublist. It has two types of cheese defined here. That's why inside that item, the cheese item, we create another list to capture its subtypes, which here are blue cheese and feta. So logically, it makes sense. Because we are defining a sublist that relates to cheese, we need to create that list within that list item related to cheese. Let's go create a sublist for our web page. In ingredients for the flour, I would like to tell our users to use 30% almond flour and 70% all-purpose flour for their cake. Trust me, it's going to taste better. To do that, I need to create a sublist for the flour. And where to put that sublist? I need to put that inside the list item related to flour. So here, inside that list item, I'm going to add my sublist here. That sublist is going to be unordered as well. I have one item for the all-purpose flour and the second item for the almond flour. And this is how it looks like. I'm telling my users to use 70% all-purpose flour, 30% almond flour for this ingredient. Pay attention that I could have used an ordered list here, like this. Because the main list is an unordered list, that doesn't mean that I have to use an unordered list inside. That's irrelevant. The only reason I have used an unordered list is because of the meaning of this piece of content. The order here really doesn't matter. And that was all for creating sublists. I have a question for you. Take a look at this. Is this a list? Well, you may say yes, it's a list of fruits. But take a look at the information that comes after. For each of them, the next information is something about taste, sweet, sour, tart. Then it's something about color, red, yellow, blue. And then we have something about season, fall, summer, winter. Is list a suitable structure for the content that we are trying to show here? My answer is no. But do you know any better structure for showing this content? A table. This is an example of tabular data. We have some items, apple, mango, lemon, blueberry, and we are capturing the same property, taste, color, and season, for each of those items. Let's learn about HTML table element for capturing tabular data. First, let's understand what is tabular data. Tabular data, the data that is captured using tables, has two dimensions. The first dimension is the properties, and the second dimension is the instances. The idea is pretty simple. You have some instances, in this case I have some users, each of them will be a row in my table, and then I have some properties for those users that I would like to capture. I have their username, their name, number of posts they created, comments, and so on and so forth, and I would like to capture that property for all of the users that I have. So in this table, each row represents a user with all of its relevant properties. How can I add a new user? I just need to add a new row for that user with its data. And if I want to remove a user, I need to remove a row. So the information for different users in this table is captured row by row, and each row corresponding to a user. We'll get back to this row by row idea when we're writing our first HTML table. Let's take a look at another table and talk about its structure. I have another table here capturing different categories of expenses for different months of a year. And at the bottom, I have a total row capturing the sum of all the expenses for each month. A table has three main regions. First is the header part. In HTML, it is called thead for table head. Then we have the table body part, and the bottom part is the table footer, the tfoot. The table head represents the structure of our table. It captures the labels for different columns that we have. For example, the first column label is category, and it defines that the information that is going to come in this column are about category. Same is true for the other columns, like this one, which captures that these expenses are for the month March. After the header, we have the table body, where the actual data of the table lives. For example, here, we can see that for the gas item, we have this amount of expense in the month of February. So the actual data goes inside the table body. And finally, we have the table footer, which captures a summary of the table data. These are the three logical regions that we have in a table. Now, all is left is to see how to capture the data that's in the table row by row. I'm going to bring 3 sample rows, one from the head, one from the body, and one from the foot, to the next slide, and we can see how's that going to work. Each table row in HTML is captured using a tr tag, like this. Whether that row is in the body, the header, or the footer, it really doesn't matter. It is still captured using a tr tag, which stands for table row. Then, for each row of the table, we capture each cell. And each cell can either be a table header or table data. The table header acts like a label for the row or the column. Here, the text rent defines a label for this row's data. So for the first row, we have these cells, and all of them are just labels. These are table headers. For the second row, we have already seen it. The cell with the text rent is table header, and the other 4 cells are TD, table data. And the last row, which relates to table footer, has the same structure. The first one is a table header, and the rest are table data. Now let's go and see some concrete examples. Here's a sample table in Google Sheet that I would like to create using HTML. As you can see, the table follows that familiar structure. We have the head section, the body section, which holds the data, and the footer section, which holds the summary. So let's create this structure first. I need the table element. Inside that, I need the table head. Then I need the table body. And then I need the table foot. So these are the 3 sections that I have in this table. Then the table is created row by row. So I have 1 row of information inside the head, 3 rows inside the body, and 1 row inside the footer. Let me add them. That's 1 row inside the head, 3 rows inside the body, and 1 row inside the footer. Now I need to capture each table cell. So starting from here, the first cell is username, then name, then country, and so on and so forth. Now I have a choice to make. Is that a header or is that a data? Is that the label for the column or the row that I have in this table, or is that actually a data? Here, the username, of course, is the label for this column. And that's why I need to use th, table header, to capture that cell information. Let me do that. That's first row, the first cell, it's going to be username. Next cell is going to be name. Next one is going to be country. And I'm going to do the same for the remaining cells. Very well, I have finished the first row of my table. And that row belongs inside the thead, the header of my table. Then I need to enter the data for each user inside this table. So for each row, I need to capture the information for each cell. This is something you're already used to, but right now you're doing it with tag. That's why it might feel a little bit weird. Let me show you on Google Sheets. If I want to add a new row here, let me add a new row below. You see that it gives me a chance to enter the information for each cell. So for example, username, let me put my name. Then if I press tab, I go to the next cell to enter the name, then to enter the country, and so on and so forth. The same thing happens here. So inside that row, that empty row, I need to capture this information for this user. So I need a TD because it's a data. It's a username of that user. So I need to capture that using a TD element. And then I put that information inside. Let me copy paste it. And I put that inside that tag. Then I go to the next cell. Another table data. This time I'm capturing its name. As you can see, it is shown under the name. Let me do it for the remaining field. So I have started from username and entered the information one by one. Exactly the same thing that I do when I'm entering a new row in the table. Let me do that for the remaining 2 users. I can reuse this part. Very good. So I have entered 3 rows for 3 users that I have in this table. And that is the result so far. Here, as you can see, each row corresponds to one instance. Here, this is the table of users, so each row corresponds to one user, and it captures all the information related to that user. The table head, on the other hand, gives us the label for these information. For example, we know that the first one is about username, the next one is about name, then we have country, and so on and so forth. Very good. We have one more row to capture, which is in the table footer. So let's go add it. I go inside the table foot. I have a row. Now tell me, is this one a th or a td? Is that a header, a label, or a data? It's a label for this row, which shows that this row is capturing a sum. So let's add it as a th. And the rest of them are tds. These four are empty, and the last one has a data in it. And there we have it. We captured the same tabular information using a table inside HTML. You may be asking why this table looks as ugly as it is. And I give you that. It does look ugly, but semantically, meaningfully, this table is correct, and this structure is correctly captured using HTML tag. As you probably remember, the meaning is the concern of HTML and not the style. The style was the concern of CSS. Let me add some style to this table. I'm just going to copy paste it. Here we have the same table structure with some added styles, and it now looks more tolerable. We will learn all about the styling later on in CSS. Let's see another example and add a table to our cake page. I want to add a table about nutritional facts. Let me show you the table first. Here's the table that I want to add. This is its header part, and this is its information. So these three rows is going to be in the body. The first two rows is going to be in the thead. And we have some differences here. We see that this has spanned across two rows, and this has spanned across three columns. So this is bigger than one cell. We would like to see how we can capture that in HTML. It is going to be very simple. Let's get started. I'm going to add it before the glossary section. Let me add a heading 2 with nutritional facts, and then underneath it, I'm going to create a table. My table has a head section and a body section. I don't have a footer section for this table. That's okay. For the table head, I have 2 rows, and for table body, I have 3 rows. Let me add them. There we go. These are the rows that I have. Now let's start from the first row. In the first row, I have the ingredients and the text per 100 grams. And these are the table head information. These are labels. Let me add them to the first row. In parallel, based on what I'm doing in the HTML, I'm going to recreate this table here so that you understand that doing this thing is not something new. You're already familiar with it. Let me do that. So on the first row, I have just created 2 cells with these informations. So let's start from here, and let me add those 2 cells with the same information. All right, now I'm at the same point here and in my HTML. The next thing that you do here naturally is that you merge cells. So I need to merge these 2 cells together to make it look like this. And I can easily do that by coming here and clicking on merge. I can even center that if I want. Let me do it so that it looks better. And then I need to merge these 3 together. Let's do that. There we go. So all I needed to do is to span this and merge this with its next 3 cells and this one with the bottom cell. And here's how to do the same, this time in HTML. So the ingredients needs to span to the next row. I have a property called rowspan, and I want it to span 2 rows. That's why I provide 2. And this cell had spanned 3 columns. So 1 column, 2 column, 3 column. I need to capture that information using colspan attribute. Let me do it again, this time faster. So I have started with this. I have just 2 cells. And then I span this one 2 rows, like that. And then I span this one 3 columns, like this. All right, so I'm done with the first row. For the second row, this one has already been spanned. And I need to capture these 3 cells. Let's go and do that. Those are also labels and not data. That's why I'm using th. Very good. So I'm done with the second row also. And let me do the 3rd, 4th, and 5th row. Each of them will have 4 cells, and these are all td, table data, and they are inside the rows which are in the tbody. Let me add them. Very well, so we have captured the same information for this table using HTML table elements. We have seen that this is achieved by merging cells. We can merge to the next row by using rowspan, and we can merge to the next columns using colspan. It's the same idea, this time captured using tags. Let me add borders to this table so that you can see that we have done it right and exactly the same. And here is that table. I like to talk about HTML spec, browsers, and MDN. I think you're going to like this one. Take a look at this example here. I'm on example 3 file, and I have created a list with a sublist inside it. So I have tea and coffee, and tea has sublist, which is green tea and black tea. Everything looks normal. But based on what we have learned about creating sublist, is this structure correct? Do you remember that I told you a sublist needs to be inside an item because it's a sublist of an item. Therefore, this structure is not semantically correct. And if I want to correct that, I need to move this and put it inside the T because it's a subcategory for the T. As you notice, the style hasn't changed a bit because HTML wasn't about the style anyway. So the style is irrelevant to the correctness of our HTML. But HTML has a lot of rules. That was one example, and we're going to learn a lot of tags, and those tags are going to have a lot of edge cases and rules that you need to follow in order to write correct HTML. How on earth you're going to remember all these rules? Well, mostly you don't have to. Let me put it back to how it was. If you remember from section 1, when we created the BTML format, we have created a tool called the Validator so that our writers could validate their book data and ensure that it's correct. HTML has the same thing. Let me search for HTML Validator. This is a website that helps me with HTML validation. I have 3 ways of giving it my HTML file so that it can validate it. Here you can provide the address to your website. You cannot use this address here on top. We'll learn about why in the next section. But for now, you can use either file upload or direct input. I'm going to use direct input because it's simpler. I'm going to copy paste everything, paste it there, and then I'm going to click on check. Here you see that it actually caught this error that I made on line 13. It is telling me from line 13 there was an error, and that error is the UL is not allowed as a child of a UL. So I cannot have a UL to be a child of a UL element. Here it is telling me, in somewhat technical term, that I can use 0 or more li element inside the UL tag. So that means I can only have li elements as child of UL, and therefore I need to move the sublist inside the relevant list item, which is T. All right, let me copy it again and put it there in the box, click on check, and now I see the check has passed. Now I have more confidence in the correctness of the HTML that I have wrote. Let me put it back to what it was again to show you something else. I'm going to add a few more elements here. I'm going to add a section, and inside that I'm going to create a paragraph. The text for the paragraph, I'm going to type lorem and press enter. This is just a dummy paragraph that you can create by typing lorem and pressing enter. And after the section, before the list, I'm going to add a BR tag for line break. Very good. So now let's validate this page. Copy paste everything, paste it inside the validator, click on check, and scroll down. Here you can see 3 types of messages that the HTML validator is going to give you. We have error message, that one we have already seen. We have warnings, it is telling you there is something wrong, but it's not as severe as an error, but you still need to fix it. Here it is telling you that the section lacks heading, so it is asking me to add a heading inside this section so that we know this section is about what topic. The last type of message is info. That is just for your information. It's not an error, you don't have to fix it, but it is telling you that you can get rid of it if you want. In this case, I don't even recommend you to bother with fixing this. But let me fix the warning and the error again. So I need to add heading level 2. I'm going to put a dummy text there, lorem. And let me fix the list again. I'm going to leave this to be here. Let me copy paste, put it back there again, check. And you can see I still have that info message, but my document check has passed and I don't have any issue in my document. Very good. Let me remove everything, create the boilerplate, and I want this time to remove the head section. As you know, the head section is required. You cannot have an HTML file without the head section. Let's validate that. Here you can see the error that it is telling you that head is required, and you can go and read about the head element in the MDN documentation. Here I see that there is a link that probably goes to documentation. Let me click on it. It did not open the MDN website which holds the HTML documentation. This is a new website that probably you haven't seen so far. Let's maximize it. This website's URL is html.spec.whatwg.org, and it is telling you some information about the head element. It is a huge web page that holds a lot of information related to HTML. But here you have also the links that takes you to the MDN for the head section as well. But what are all these websites? Why we have two different websites documenting HTML? And what is the relationship between this website and the MDN? Let me tell you their story. When it comes to HTML and the web, there are four parties involved in this. The first party is the users. These are the people who like to browse the web and take a look at different websites that they're interested in. These are good old normal people that they have the computer, but they need a software for browsing the web. That's where the web browsers company come into play. These companies want to build the software, the web browsers, that users use to browse the web. And we have many such companies that create browsers. Some of them are familiar to you and some are not. On the other side, we have the web developers, which is you. You want to create websites for your users to use. A website is just a software that you create, and you have some users that will be interested in browsing your website. Here's how it's going to work using these three parties. So the users are interested in your website, but they need a software to interact with it. So that's why they need a web browser to do that. And you, who are creating a website, need to create it in a way that those web browsers could run and show your web page to the end user. Without a shared and common standard, these browser companies can create their browser in any way they want. So they will create different softwares. All of them are called web browsers, and they are capable of doing different things. Your users have the freedom of choice to download and use any of these browsers. And you, knowing that as a developer, need to create your website so that it can be viewed on any browser. That's why we need to share the standard, so that you could create your website and your users using any browser can visit that website the same way. Without that shared standard, you would need to create your website for a specific browser like Chrome, and then your website might not work on the Edge. Or you may have to create a second version just for the Microsoft Edge. To solve this problem, we need a fourth party, an organization that is made by the big companies behind web browsers. That organization is called WHATWG, which stands for Web Hypertext Application Technology Working Group. This organization's job is to define web standards. So they want to create a standard about what web is and how it works and the technologies around it, so that we solve the problem that we've seen earlier. They have defined many standards like DOM and fetch that we're going to learn at some point. But the most important standard that they have defined is the HTML, the hypertext markup language. So HTML is a living standard. It's basically a document that defines all the rules and ideas behind this technology. And this is called HTML spec, HTML specification, defining exactly what HTML is and how it should be used. So this WHATWG organization does not create any software. They just create a document telling you that this is the standard called HTML and this is the specification of how it should work. Now here's how all parties are going to work together to create the experience that we know as web. First, the web browser companies are going to create their web browser that is capable of showing HTML documents. So no matter which company it is, all of them are going to create their software in a way capable of showing HTML documents. Then you, the web developer, will create your website based on HTML language. That's why you're learning HTML in this course. Now the users who want to browse the web can download and use any web browser that they want, and using that, they can visit any website that they like. Because the web browser software and all the websites are following the same standard, which is HTML. I'm going to go out of the script a little. When I was learning web development and HTML for the first time, I wished there was someone to explain me these concepts back then. And if I am that person to you, that makes me really happy. Alright, now let's go and take a thorough look at the MDN and HTML spec website. Go to your browser and search for HTML spec. You see that the first link is from WHATWG organization. Click on this. This is the HTML Living Standard. As you can see, today is March 13, and this document has been updated yesterday. So it's a living standard. That means it's updated regularly. Down here, you see the table of content with all the information available inside this standard. Here, for example, section 4 is about HTML elements. That's what we're learning in this course. But this standard has other sections, for example, related to web workers, web storage, and so on and so forth. You are not the only one who's using this standard. The companies who are creating the web browsers also need to use this standard. So this is not just something for web developers. Under the HTML elements, I can see different elements that are available inside an HTML document. Let's go take a look at the head element. Here you can see all the specification that this standard has defined for the head element in HTML. And it is describing that head element represents a collection of metadata for the document. The same idea that we learned in the section 1. Now there is a link to the MDN documentation. Let's click on it and open it there. First, which company has created MDN? Well, if you scroll all the way down, you see Mozilla, the company behind Firefox. You can go to their website if you want, and these are the products that they have. So what's the purpose of having another website for HTML documentation? If you go to the homepage of MDN, you see that this documentation is tailored for the developers, the people like you who want to create websites for different browsers. And here you have the documentation for different technologies available on the web: HTML, CSS, JavaScript, web APIs, and so on. So for web developers, this is a more suitable source of documentation. But everything you find here is completely consistent with the HTML standard. The MDN has just been tailored for web developers. Let's take a closer look at MDN. Let me go to the HTML part. Here's how the documentation is structured. You have some guides and how-tos, which are more like articles about a specific topic. Here, for example, responsive images. And then you have the reference for different parts of HTML language. Let me find the head element again. You have a description for this element, the attributes that is used on that, some examples, and then you have a technical summary. Let's take a look at this. Let me put it side by side with the HTML standard. Here you see the same content. You have categories as none. Then you have a part about permitted content, which is this one, the content model, tag omission here, and so on and so forth. Then you have a link to the specification itself, which is going to open the exact same page on the HTML standard. And finally, we have browser compatibility. That's something we need to talk about now. Let me show you something first. If I take a look at the elements list that I have, I see some interesting icons. For example, this. Some of them has this icon around it, and some of them has the bin icon, the garbage bin icon. Let's see what's that about. Let me open these. Here you can see that this tag has been deprecated. That means this tag has been removed from the HTML standards. What about the other tag with this icon? This icon means that this tag is experimental. It has not been fully added yet to the HTML standards. That's why HTML is a living standard. New things get added and removed all the time. And the browser companies are not the one changing the standard, but they are implementing the standard on their software. So when a new feature gets introduced in the HTML standard, it will take some time for the browser company to implement that feature in their browser. That's why not all parts of HTML are supported by every browser. Most of it is, but not all of it. Let me show you. There is a website called caniuse.com. Here you can check which feature of HTML standard you can use and which browser companies has already implemented that in their browser. Let me search for head as an example. Here is the HTML element head, and this is a table for browser support. The numbers that you see here are software versions for different browsers. For example, the Opera browser version 10 to 12.1 does not support the head tag. This version of the browser has been released from 2009 up to 2012, and currently, based on the stats that this website has, 0% of the users use this browser. So if you create your web pages with the head element, and one of your users uses this old browser, then probably they're not going to see your website the way you intended. But on the newer releases of the Opera, which are more recent, this feature, the head element, is supported. And you can see that almost 0.4% of the users use this kind of browser. So the head element is very established with very good percentage of support, and mostly all of the browsers support that element. Now let's see the font element. The font element, if you remember, was a deprecated element. That means this feature is being removed from the standard, and it is recommended that you use CSS fonts instead. But take a look at the table of support. We can see that a high percentage of the browsers support this feature. Here's the reason for that. We have a lot of websites that has been created with the older standards of the web. And in those older standards, the font element wasn't the deprecated element. So the web developers have used that to create their websites. But now this element has been deprecated, and the new developers are recommended to not use this feature again. But the browsers are going to keep supporting that element to ensure backward compatibility, to ensure that the old websites will still work on users' devices. That's how they will ensure, as the web standards evolve, the web will not be broken, and it will keep working for the older websites as well. And finally, let me show you an experimental element, the fence frame. Let's search for it. For this element, which is new and experimental, you see that there are not many browsers who support this feature. For example, Safari and Firefox does not support that, but it is supported on Chrome. So if you are creating a website and you know that your users may use Safari or Firefox to access it, you may not want to use this element because their browsers does not support it. But if you're sure that all of your users are going to use Chrome for that website and you need to use this feature, then you can go and do that because it is supported on Chrome. And that is the idea behind this browser compatibility table. It is briefly letting you know which browsers have implemented the support for this feature. Now I think you have a clear picture of HTML and different parties involved in this technology. Let's take a look at HTML textual elements, zoo. Why zoo? The term zoo here is intentional. Let me tell you why. Imagine you want to visit a zoo. In this case, it's an HTML zoo, where you're going to visit different HTML elements. I personally rather to see animals. What I want from you is to treat this experiment as visiting a zoo. When you're visiting a zoo and going to the lion section, you don't stand there and try to learn every bit of details about lion and its life. You don't just stand there, learn about its biology, how it behaves, when does it sleep, how many hairs is in its head, so on and so forth. You don't stand there the whole day. You're just going to watch it, see it exists, and you're going to move on. And if later on you see something like this in the wild, you know it's a lion. That's exactly how you should visit the HTML elements that we're about to see. Here I'm looking at the file zoo.html, and it is an HTML zoo for textual elements. Here we have a big style tag with a lot of CSS inside just to make the page more presentable. So for now, just collapse it so that it's not in our way. As you can see, it's about 500 lines of code. Let's get to our HTML zoo. We learned about heading elements from heading level 1 to heading level 6. We have a new element here called heading group, and it is a group of headings when you want to have a subtitle or a tagline for your headings. That's its use case. That's what you're visiting in the HTML zoo. If you later on need to learn more about this H group, you can just hover on it, and then you see a link to the MDN documentation. And you can read the documentation and see more examples for yourself. Let's continue. We have the block level text. You're familiar with the paragraph. We have the pre element. Pre stands for preserve, and it is preserving the white spaces exactly as you type them. For example, here with these indentations and empty spaces, those are exactly captured as you type them in the HTML. Next, we have the block code element when you want to code someone and cite them, as you can see here. We know what an HR is, a horizontal line, as you see here. We have already seen it. Next section is about inline text semantics. We learned about B and a strong tag, one of them for semantic reasons, the other just for visual purposes. Same thing with the I and M tag, M for emphasis and I just to make them italic. Their default style, both are the same. We have U for underline, strike through for this. You can see one example of using a strike through is when you want to put discount on your website. We have the mark element for highlighting text. The small element for when you want to put a copyright information or something at the bottom of your web pages. You can use the small tag. Let me open its documentation. So here it suggests that it represents site comments and small prints like copyright and legal text, as the example shows here. Next we have sub and sub, as we have used them in our lesson. Next we have del and inst tag represent deletion and insertion to the document. So here, for example, the event was on Friday, March 14th. This has been deleted from the document, and this has been inserted. So it's a new date for the event. It has been delayed a day. Same way can be used with the price. Then we have the abbreviation element. So here, for example, the abbreviation is HTML, and it stands for Hypertext Markup Language. And if you hover on that and keep it still, you see that text appearing there. DFN stands for define. It wraps the term that you want to define. So here we're defining HTML semantic in this text. Cite works as a reference to a creative work. So here, for example, we're putting cite around the name of this book. Q stands for quotation. It adds these quotation marks around that piece of text. Next, we have the code element that wraps the computer code, a fragment of computer code. What are these? Here you can see this is translated to that, the less than sign, and that one is translated to the greater than sign here. These are called HTML entities. Let's learn about them here. I have opened an empty Google Docs because I want to explain to you this concept. Take a look at the keyboard that's in front of you, or imagine one. A keyboard has limited space. It has limited number of keys that you can fit on that board. Now, can you type all the letters and characters available across the globe using the keyboard that's in front of you? And the answer is no. Because that keyboard has limited space, you can't possibly have one key for every character in the world. That's going to be a huge keyboard. Therefore, for entering symbols and some special letters, you need a different method. In Google Docs, you can go to the Insert menu under Symbols, in special characters. Here you see a menu of special characters that you can insert in the document. Here there are different categories. For example, emojis. If you want to insert them, because there's no emoji on your keyboard, you need to use a special character for that. I can add these to my document by just selecting them. Here's what I want you to notice. Take a look at this. All of the symbols, as I go through, have this number associated to them. A U plus, and then a 4-digit. This code that you see here is called a Unicode number. And Unicode is just a table. Let me show you the Unicode table. Go to this first website. This is the Unicode table. There are a lot of characters in this table. It's going to be a huge table. As you can see, this starts from 4 zeros, and each character just adds 1 to it. So it's a table of numbers that map to a specific character. Here, for example, that character is a null character. Let's go search for this number in that table. Here on the top, I can select search, put that number, and I see the rightward arrow. Here you can see more information about this letter. If you go to copy paste, you can see the exact code that you can use for HTML. That was just to give you a taste. Let's go and focus on the part that we actually care about. So, to use any of these special characters in HTML, this is what you need to do. For example, let's try to use this one. This has this Unicode. I'm just going to copy its code. Anything that is after U+, 29E, I'm copying this. Then in your HTML, you can put @x and then enter that number and a semicolon. So any special character that you need to add to your HTML, you can easily do that by entering its Unicode in this format. Moreover, some of those useful Unicode characters has been defined using HTML entities, a little bit more readable form for writing. So for example, here, LT stands for less than sign. That's why it maps to this one. And GT stands for greater than sign. That's why it maps to this one. You can press and then start typing something. For example, a square. I have that one and I can use it and it looks like this. You can play around with it. You can also search for HTML entities on the web. But that's really all there is for writing characters that are not present on your keyboard. Let's continue. KBD stands for keyboard input. SAMP is for sample output. var is for variable. Time is for capturing the time. This is the human readable way. And then it has a datetime attribute that captures that information using a machine readable way. Same with the data. Humans read USB-C hub, and computer can see that this relates to SQ number. This, that relates to a product in a store. And there are more elements that you can go through in this section. Let me move to the next section. This section is about the structural elements. We have the header, nav, main. We can have section, article, side column, address. That one we didn't see. Let's go take a look. As you can see, it captures contact information for the nearest article or body element. And we have footer, which we're familiar with. Here's the list. We have the unordered list. Here you can see sublist being captured for dairy and vegetables. We have the ordered list with the sublist again. And the description list to defining terms and their description. It can also be used for FAQ. So it will be questions and the answer to those questions. We haven't seen menu, but it works exactly the same as unordered list. It is usually used to capture the toolbar items. So for example, this button will make the text bold and so on and so forth. Next, we have the figure and figure caption, which captures some figure and it adds a caption to it. It can get a code, it can get an ASCII art or anything like that. Here you can see the sample code. Next, we have details and summary elements, and it looks interesting. You have a details tag. Inside it, you put a summary and then a paragraph. So this is a summary of that paragraph. And if you want, you can expand it and see the full thing. So in this case, it is used to capture the FAQ in this interesting format. Next, we have the dialog element. That's an interesting one. So here we have a paragraph. This is a dialog element, and we have a close button, but we don't see it on the page. We need to add the open attribute to the dialog element so that the dialog will open. Let me add that attribute. So just add an open attribute, and you can see that the dialog is opened on the page. And if I remove that open attribute, it's going to be closed. Of course, on a real website, you will use JavaScript to open and close this dialog automatically when user clicks on different buttons. But for now here, we can see how it's going to work. Next, we have these interesting elements. First one is the progress bar. You can change this value, maybe set it to 10% or 100%, make it complete. This shows the progress bar. So for example, if you're downloading something, you can show that progress bar to your users. If that progress bar is empty, this browser by default is showing this status. That means it's indeterminate, something is pending. Then we have the meter, which shows you a measurement. Can you remember where you have already seen this element being used? Let me bring it up. Just search for password tester. That one is okay. And here it is, just to start typing, and you see that element working here. So using that element, you can provide a measurement to your users. Here, the measurement is about the strength of the password. We have the same thing here. I encourage you to go and play around with these values and see how it works. And lastly, we have some HTML entities that we have already talked about. Here are some of the tags that we have learned. As you see, we have the opening tag, then we have the content in the middle, and a closing tag comes at the end. So the textual content, because the content itself is just text, the content goes right between the opening and closing tag. But what about the non-textual content, like an image? How can we capture that in HTML? We write our HTML inside an HTML file. Here the name is index.html, and that image is in a separate file. The file name here is cat.jpg. Images are saved in a separate file, and we cannot capture them the same way we capture a textual content in our HTML. We cannot have an image tag like this and then put that image somehow in between. That's not how it works. An image is not a piece of text that we can copy paste in between two tags. So we need another way to capture non-textual content in our HTML. Since we cannot put that image directly in between our tags, we don't need the closing tag and the content area. So our image tag is going to be a self-closing tag. And then we are going to add an attribute to our image tag. And that is called src, which stands for source. And its value is going to be an address to an image file. Here in this case, the file is cat.jpg. That's why images are external contents. We can't capture the content of an image directly in our HTML file, the same way we can do with a paragraph and capture it there. Therefore, we need to provide an address that leads to that image file. And that address is what we capture in our HTML. This is a pattern for all the external contents. Here are some examples. We have seen the image, we have audio and video, those are external contents too. We can have script files like app.js for a JavaScript file, and that is captured the same way. It's a separate file. We capture the address that leads to that file in our HTML. But what does that address exactly looks like? Where can it lead to? Where that image file can be? Well, it can be on your computer, the same computer you're coding with and watching this video. It can be on another computer, which is in your home network, could be your TV or your desktop computer. Or that image can be on any computer in the world that is part of this huge network called Internet. So, first thing first, we need to understand Internet, what it is and how it works. We need to see concrete examples for this concept to sink in. Once we have that understanding, the rest of the things are going to be easy to pick up. Let's get started and understand Internet in the next lesson. Let's learn about Internet, a network of connected computers across the globe. But first, let me motivate this idea about why do we even care to learn about the Internet. I'm inside section 3 taking a look at example 1.html. Take a look at this HTML file. Here we have a simple web page with two images of the same cat. The first image source is in images cat.jpg. If you take a look at your file explorer, you should see an images folder, and then we have the cat.jpg file. That's the same image. So the source of the first image that you see here is coming from your computer, and that image is located right here. But what about the second image tag? What is this? Well, that is an address that leads to an image, and that image looks exactly the same. But where is that image? Where is it located? That image exists on a computer somewhere in the world. But where exactly? Let's see where is that computer. I'm going to copy this address and search for IP lookup. I'm going to click on this link. In here, just paste the address that you have copied for that image and click on IP lookup. There it is. That's the IP address of a computer that has that image of the cat saved on it. We don't yet know what this means, but that's okay. Let's continue. Down here, you can see more information about that computer. You can see that computer is in Sweden. It is in the city Stockholm. And if you want, you can view it on the map. That's the approximate location of where that computer is located on the planet. In this section, we are going to focus on the idea of internet, how this address actually works, and how is it that we can take a look at an image that is placed on a computer in Sweden just by typing this address. In this section, we are going to answer what internet is and how does it work. Through doing that, we're going to learn all about path and how to use external contents in our website. Once we've learned that, the idea of World Wide Web will become clear to us, and we will learn how to deploy our website on the web for others to have access to it. Let's get started. So internet is a network of computers throughout the world that are connected together. When I'm talking about the connection between those computers, I'm not talking about anything abstract. I'm talking about something concrete, like physical connections through cables all across the globe. I'm pretty sure that you have heard the idea of cloud, that nowadays everything is on cloud. And that is the term that people usually use when they talk about resources on the internet. But we need to get to the bottom of this and see the internet for what it really is: a physical connection between computers across the planet. Let's take a look. Starting from your computer at home, your computer is connected to the internet because it is connected to an internet hub. Probably that's something you bought and you pay for that monthly. So your computer is connected to that hub either through cables or through Wi-Fi, which is a wireless form of connection. Both of them doing the same thing. From your internet hub, there is cable that goes outside your house. Your cable, same as your neighbors, are connected to the larger network of cables that span in where you live. So there is real physical connection between you and other part of the city. There are dedicated places called data centers where they have hundreds of computers stacked together and connected through cables. A lot of the services that you depend on throughout the day, like online banking, are relying on these computers to work. And that's not merely enough. If we want to connect computers across the globe, we need to connect continents together. So we need huge cables that run under the ocean and connect the continents together. So this idea of internet and connecting all these computers in the world together requires a ton of infrastructure to exist. And that part, thanks God, we don't need to worry about it. It has already been mostly done. So we have some computers across the world, and now these computers have physical connection together. Now we would like these computers to communicate together. But how they can do that? First, each of these computers needs to have a unique address. For example, if this computer wants to talk to this computer, it needs to have its address so that it can send message to that computer. It's the same idea with posting a parcel. You need to know the address of the receiver. Otherwise, you cannot send the parcel to them. Here's how we do it. We start from the first computer, give it number 1, second computer number 2, third computer number 3, and each of them will get a unique number that identifies this computer on the planet. Now, if computer 3 wants to talk with computer 4, because that address is unique, it can find that computer and send information to it. All right, that's the idea. But on the internet, the format of these numbers assigned to each computer is a little different. Let me show you. Each computer, instead of getting a one-digit number like 1, 2, 3, it gets 4 numbers that are separated by dot. Each number can be from 0 to 255. For example, this computer's address is 104.28.127.62. But it's the same idea. It is a unique number that is assigned to this computer to identify it across the world. That address is unique to this computer, and no other computer in the world has this address. This is called an IP address. IP stands for Internet Protocol. So it's an address that uniquely identifies computers that are on the internet. Its format looks like this. It's just 4 groups of numbers. Each of the numbers are from 0 to 255. An example will be like this. There are many interesting reasons behind why a computer address looks like this. These IP addresses have some interesting properties. For example, they are assigned to computers based on the regions that they are in. So there are specific ranges of the IP addresses that are assigned to specific part of the world. That's why from an IP address, you can approximately know where that computer is on the planet. It is just like having a full postal address to a place. By having that address, you know where that place is on the planet, and you can send your packets to that address. You can communicate with that address. The IP addresses is the equivalent idea for the computer world. Let's go take a look at few of these addresses and see where they are on the planet. Let's take a look at this one actually. So this is the same IP location finder, and here I'm going to insert this IP address and see where it is on the planet. So it starts with 72.49.207.64. Let's look it up. We can see the IP address is this. That's what we inserted. And it's located in United States, Ohio. So the region is approximately there. We can take a look at it on the map as well. There are other interesting tools in this website that I'd like to show you. Let's go to the tools section, online tools. I want to see IP tools. First tool is called IP converter that converts the IP into different number formats like decimal. Let me paste it and convert. There it is. You see the IP of that computer in different formats. Here, for example, decimal. So this number is just a unique number that identifies this computer on the planet. It has been written in this format, but the idea is the same. You can also see the location is mentioned here. Let's use another tool. Let's use this one to convert IP to ASN and see who owns this IP. Let's see what results does it return. Paste the same IP and submit. You see that this IP belongs to this company that is located in the US. You can read more about ASN here. Let me show you this. Let me open a new tab and search google.com. You see that I'm on google.com. What happens if I look up the IP address associated with this? Let's copy it, go to IP lookup, paste it, and see what do we get. Well, we see that computer is placed in California, and this is the IP address for that computer. What happens if I copy this, create a new tab, and paste that here and enter? Well, let's do that. I'm again in google.com. We're going to talk about this exact idea, the domain name. How we can buy a domain, what does it do, how to set it up, and why do we even have domains? Let's learn about domain names and DNS in this lesson. We learned about IP addresses. So the computers that are part of this global network of computers called Internet, each of them will have a unique number that identifies that computer across the globe. And that number is called the IP address. And the IP address is what allowed the computers to find each other and communicate. So for example, this computer on the internet can find and communicate with other computers by knowing their IP address. By the end of previous video, we did something else. We look up the IP address that is associated with google.com, and we saw that the IP address is this one. Then we went on and typed this IP address in the address bar of our browser and pressed enter, and we saw that we arrived at google.com. We're going to talk about exactly that. The domain names like google.com and its relationship with IP addresses. Let's get started. Imagine that this is your computer and you would like to visit Google website. So Google is a website that is hosted on one of these computers that is on the internet. For you to visit Google website, you need to know which computer on the internet is hosting the Google website. Once you figured out the address of the computer that is hosting Google website, your computer needs to communicate with that computer so that you can visit Google website. And that is exactly why when you write the IP address of the computer that is hosting Google website, you're going to see Google showing up on your browser. But we, humans, unlike computers, are not really good at memorizing numbers. I don't like to memorize this number and type it in whenever I want to visit Google website. So there has to be another way. That alternative way is called domain names and domain name systems, or DNS. These domain name servers are computers that are part of the internet, and they have been designed to solve exactly this problem. We humans are not good at memorizing numbers, but we're good at memorizing names. And the DNS server's job is that you will give it a name, and it gives you back the IP address that has been assigned to that name. That's all it does. It needs to capture a simple label value data, where label is the name and the value is the IP address associated with that name. So it's just a simple table. On the left, we have the domain names, and on the right, we have the IP addresses associated with each name. And here's how internet works using this DNS servers. You, on your computer, would like to visit Google website. You know its domain name is google.com. So that's what you're going to search for. You will put google.com and press enter. Your computer will ask a DNS server to give him the IP address that is associated with google.com. And that DNS server will take a look at its table, see the associated IP address, and it's going to return that IP address to you. Now your computer has the IP address of the computer that it needs to communicate to get you to Google website. Now you, as a human, can remember the names of the websites that you're interested in, and that name, using these useful DNS servers, is going to be resolved to the IP address of the computer that you need to communicate to in order to visit that website. And that is the idea behind domain names and domain name servers. Now, how can you get a domain name for your website? All you need to do is to buy the right to use a domain name. For example, the name bookearlier.com, you buy its right, you buy that domain name, and then you can assign it to any IP address that you would like. If you assign that name to the IP address of a computer that's hosting your website, then anyone, by typing this, bookearlier.com, in their browser, they will be able to communicate with the right computer and visit your website. Let's go and see all of that in action. In your browser, just search for IP lookup and go to this website. That's the website we have seen in the previous lesson. And here you can see that they can find the IP address by providing the domain name. Let me provide the domain name google.com again and click on IP lookup. This is the IP address that's associated with google.com. But how did this figure it out? Well, that's the job of DNS server. Here on the right, we have a tool called DNS lookup. Please click on it. This is a DNS lookup tool where you can provide a domain name like google.com and get back the IP addresses that has been associated with that domain. Let me provide google.com as an example, and let's look up DNS records. There are different types of information that you can set on your DNS. What we are looking for is an A record. A stands for address, and that record provides the IP address of the computer that is associated with this name. So here you can see that we have A record, an address record for the name google.com, and the IP address assigned to this name is this. That's the IP address that we got when we looked up for google.com. Let's go visit the DNS server directly and look up this name ourselves and get back the address that has been assigned to this. If you scroll down in this page, you see that there are some DNS servers that has been listed here. The first one is Google DNS server. That's what we're going to take a look at. So it's 8.8.8.8, a very simple address. Let me copy it, put it on top, and press enter. This is Google Public DNS. you can provide a domain name and get the records that are associated with that domain name. Let's put google.com and click on resolve. Here is the answer. As you see, by default, we are looking for an A record, an address record. That's what we got back. And the data is the IP address that has been assigned to that name. And finally, before we go and buy our own domain, let's take a look at DNS propagation map. Let me search for it. Here's the idea. For me, who is located in North America, if I register a domain name and assign it an IP address, it will take some time for that record, that name to IP address record, to spread across the globe so that all the DNS servers that are located across the globe will recognize that this name resolves to this IP address. And that is what this map is showing you. You can look up a domain name and see in which areas of the world your domain name record has been synced and propagated. So for example, let me search for google.com domain. It is a well-known domain, so all the domain name services across the globe should have that record in their system. So we should get green marks on all of them. Let's search. As you can see, that domain name is well propagated across the globe. All right, now let's go and buy a domain for ourselves and change its A record to be any number that we like. There are different companies that you can buy domain name from. I'm going to use Cloudflare. Let me log in. This is my account page here in Cloudflare. You can go ahead and create a free account, and then under domains, you can manage your domains. You can buy new domains, onboard an existing domain that you have, and so on and so forth. Let's go take a look at some of the domains. Here you can search for the domain name that you would like to purchase to see if it's available or not. Let me search for google.com. You see that obviously google.com is not available. It's already been registered, but here are some alternatives for you. For example, you can buy easygoogle.net with $11 Canadian. And this price that is shown here is per year. So once you click on confirm and complete your purchase, then you're going to get that domain name under here. You can see I have bought a couple of domains here. The domain that we would like to work with in this video is this domain, bookearlier.com. So before we do anything, let's look this domain up and see if there is any DNS record that has been associated to this domain. There should be none, but let's go check it out. First, under this website, let me look up for the domain that I have. And I can see for the A record, the address record, I don't have anything defined. Under the Google DNS service, let's do the same. Let me put bookearlier.com, click on resolve. And here you can see that I don't see any answers. So that domain doesn't have an A record defined in Google DNS server. And finally, let's see the DNS propagation. You should probably see all reds across the globe. Let me put it in. Very well. So there is no DNS record that has been defined for this name anywhere in the world. Now let's go and create a DNS record for this name, an address record, and give it a random IP address, maybe 1.2.3.4. Let's see how it works. Here under the DNS, I can go to DNS records, and I can add a record here. The type of the record that I would like to create is an A record, an address record. Here you can provide the name, the IP address, which we're going to put 1234, and I'm going to turn off the proxy. I just want the DNS. Here in the name, you can use @ for root, and that @ means bookearlier.com. I can provide that like this here as well. But I also can create subdomains as easy as that. So for example, test.bookearlier.com. So if someone types this whole thing, they're going to be taken to this, and I can add multiple records for different subdomains that I have. But let's keep it simple and stick with just bookearlier.com. So now the name bookearlier.com, when I add this record, is going to point to the IP address 1234, which is just a dummy address that I'm putting there. All right, let's save and create this record, and then we're going to take a look at this map to see how our DNS record is going to be propagated across the world. So all of the DNS servers will have the information that we are setting here. Let's take a look. You can see it has started to be set here. Let's search again and again. It's in about 2-3 minutes, and you can see that IP has only been set in Amsterdam. So I'm going to keep refreshing for a couple of more minutes and see if other regions in the world will pick up. All right, it's been a few minutes. We still have it only in Amsterdam. Let's go take a look at other tools that we have. I can see that I'm seeing a record being set for bookearlier.com, and the address IP is 1234. So this tool is showing me the result. Let's take a look at Google DNS. Google DNS hasn't yet picked up my record, but that information is propagating throughout the world, and it might take a little bit of time. All right, we have a couple more regions across the globe that our DNS record has been propagated to, but there are quite a few that doesn't have our record. All right, it's been some time, and you can see that our DNS record has been propagated across the globe. Now our DNS record is available in all the regions on the planet. Let's go check the Google DNS and see if our record will come up. There it is. You can see the bookearlier.com has an A record. The type 1 is A record, and the value is this IP address, 1.2.3.4. So that was domain name and domain name servers. So domain name servers are some computers on the internet that their job is to provide the IP address corresponding to a name, a domain name, for example, bookearlier.com. You can go purchase a name and then assign any IP address that you would like to that name. Then, if your users would like to take a look at your website that is hosted on a computer like this on the internet, they don't need to memorize this address at all. They just need to know your domain name, bookearlier.com. Then their computer is going to communicate with the DNS server to get back the IP address corresponding to bookearlier.com. And then they're going to communicate with the correct computer to be able to visit your website. So the IP address and domain name will help you to find the right computer that you need to communicate with. But just knowing which computer you want to communicate with is not enough. You need to have a common language, a shared language that both of you understand, so that you can communicate effectively and exchange information. So next up, we're going to talk about this part of the URL, which is the protocol, a common language between two computers to exchange information. Let's learn about protocols, and more specifically, the HTTP protocol, which is used on the web. Here's what we have learned so far. We learned about internet and realized that we have wired the whole world together and created a huge network of connected computers. Then we learned about IP addresses, which are these numbers that uniquely identify each computer that is part of this global network. We learned that through this IP address, two computers in the world can find each other and communicate. We also learned about DNS servers, which were some computers in the world, and their reason to exist is to allow us humans to reach out to different computers by knowing their names and not have to memorize these IP addresses. As an example, Google website is being hosted on this computer in the world. All we need to do to visit Google website is to communicate with this specific computer. To do that, we need to know the address of that computer, but thanks to the DNS server, we don't have to memorize that number. We're going to memorize a name instead, which we are good at as a human, and then ask the DNS server to give us the IP address associated with that name. We ask for google.com, we get the IP address, and then we communicate to the right computer so that we can visit Google website on our computer. These are the things we know so far. Now let's learn about protocols and see why do they exist. Imagine that this is your computer. So far, based on the mechanisms that we have learned, we can find any computer that is on the internet and initiate communication. But that is not enough to have a successful communication and exchange information. Let me tell you why. Imagine that you have the phone number of someone on this planet and you like to call them. You will be able to call that person by just having their phone number. But does that mean that you can communicate with them? What if they start talking to you in Chinese and you only understand English? Well, just having their phone number is not enough to have a successful communication. You need to have a common language so that you can exchange information and understand one another. It works the exact same way between two computers. Those computers needs to have a common language, which is called a protocol, so that they can understand one another. So protocols is nothing more than agreed upon rules and formats that two computers needs to use if they want to communicate together and understand each other. Here are some examples. SMTP, IMAP, POP3. If you have ever set up your email manually, you have seen these terms. These are the protocols that computers use when they want to send and receive emails. Next we have FTP, which stands for File Transfer Protocol. So when two computers want to send files over to one another, they will use this protocol so that they can send a file from this computer to the other one. And the last protocol is HTTP protocol, which is what we're going to focus in this lesson. HTTP is the protocol that computers use on the web. So for example, if on your computer you want to visit Google, and Google is on this computer, your computer needs to talk with this computer using HTTP protocol so that you can see Google website on your screen. That's why this protocol is important to us, and we're going to learn it in this course. But here's the crazy thing. Based on what we have learned in this course, you already know the idea behind HTTP. Let me show you. When we have two parties that they need to exchange information together and understand one another, we need agreed upon rules and formats. For example, in section 1, we saw the book writers and book publishers. The book writers want to write their book, and book publishers want to publish that book. They need to agree upon the rules and formats that describe how a book looks like. Same idea applies between web developers and web browser companies. You need to write your website with agreed upon rules and formats so that the browsers can understand it and show it to your users. The agreed upon format between the book publisher and writer was called BTML. That's what we have designed in the first section. And we learned HTML, which is an agreed upon format between you, web developers, and web browser companies, and you need to follow it if you want your website to be viewable using a web browser. It's the exact same idea when two computers need to communicate together and understand one another. They need an agreed upon rules and format. In this case, it's called HTTP. It is just a protocol. A protocol is just an agreed upon rules and formats that two parties needs to follow so that they can understand each other. The term protocol may be a new term to you, but its idea is not. The idea is that we need to exchange information and we need a structured format to do that. All of these are different structured format that has been designed to solve a specific problem. Here it was about books, here it is about web pages, and HTTP is about transferring those web pages to different computers. We're going to see that shortly. The thing that's common between these three and any other protocol is structured format. And the structured format, deep down, is about a very simple idea: label and values. So in the next few minutes, we're going to learn about HTTP, and we're going to have this idea in mind and see how HTTP is structuring data that is transferred between two computers. You'll be happy to see that the same patterns you know keep repeating in different areas of computer science. Let's get into it. First, what does HTTP stands for? Well, it is Hypertext Transfer Protocol. Do you still remember what HTML stands for? Hypertext Markup Language. You see, both of them share the hypertext in their name. Here's the idea. On your computer, using Hypertext Markup Language, you're going to structure your content and save them in an HTML file. And this is your website. Then, using Hypertext Transfer Protocol, you'll be able to send your website over to another computer so that they can see it on their screen. And that's the purpose behind this protocol. Let's go and learn it. I'm on the MDN website. As we know, the MDN is a documentation source that has been tailored to developers, and it explains different web technologies. We have the web technologies listed above. Under the all, we see HTTP. Let's click on it. Here's the documentation page for HTTP, Hypertext Transfer Protocol. You can read the intro to understand what's that about. But here we have the same structure. We have some guides, which are articles explaining different topics about HTTP. If you scroll down, you should arrive at the references, where different parts of the HTTP has been described here. For example, you can go to HTTP request methods and learn about any of the available methods listed here. We will learn what these are in a bit. Do you still remember the meaning of this icon? If you remember it from the previous section, we saw it in HTML also. So these features are new features, experimental features that are being added to the HTTP technology. And these features with the garbage bin icon, these are the features that are deprecated and they are being removed from the standard. So HTTP, just like HTML, is a standard that's getting updated all the time. Similar to HTTP, there is an organization behind HTTP standard, and it has the job of updating and maintaining this standard for everyone. Let's take a look. If you take a look at the last item here, it says HTTP resources and specifications. I hope you remember that word. A specification was a document that defines the standard for this technology. It describes what it is and how it should work. And these are different specification documents related to HTTP. Let's take a look at the first document, which is about HTTP semantics, describes what HTTP is and how it should work, and it is part of the internet standard, so it is well established. Let's open it. Here's the specification document that describes HTTP semantics. Let me open it in HTML format so that we can read it better. Here you see a specification document describing HTTP semantics. It talks about what HTTP is, its purpose, its evolution, and so on and so forth. It's a very long document describing different aspects of this standard. On the HTML side, we have the exact same idea where the HTML standard is defined using this long document. So, same idea, just for different technology. On the top, you see this, Internet Engineering Task Force, or IETF. Let me search for it on Google. We see that IETF is an organization that defines a standard for the internet, like HTTP. The same way, we have WHATWG that defines a standard for HTML. By now you should notice that HTTP is like seeing the same movie as HTML, but this time with different actors. I have a question for you. As web developers, do we need to read this whole document to understand HTTP? And the answer is no, we don't have to. The same way we didn't read HTML specification to understand HTML. This standard has been written to be used by different groups of people. And us, as a developer, we have a source of documentation that is tailored to us, and that is MDN. So we, as developers, are going to use MDN to understand this technology, and we may feel the need to go and read the specification itself. But it's rare. Very well. Now you have the context and the big picture of what HTTP is, and how does it connect to all the concepts that we have learned. Now let me show you how it works, and you'll be surprised at how simple it is. Let's learn about HTTP messages, which are request and response. Here's how it works. We have a server computer that is hosting something useful on the internet. That thing could be web pages of a website, could be images, videos, or anything else on a computer. And we have clients which on their own computer would like to access the resources that are on that server computer. That could be you who want to connect to your bank server computer and check out the balance of your account. Here's how you do it using HTTP messages. You're going to send a request regarding a resource to the server computer, and the server computer is going to send you the response with the result of your request. You do that as many times as you need. You send requests, you get the result as response. Let's take a look at a concrete example right here of how a request and response looks like. Imagine that you want to go to Google website. Here's your request. You are requesting to get index.html from google.com. So you're getting the main page of google.com. And here's the response that you get. You got an OK response with the content of index.html of Google main page. So in your request, you requested for this, and in the response, you got its content as the result. That's the core idea. Now let's take a closer look at HTTP messages and see their structure. An HTTP message has three parts. The first line is called the start line. Then we have the headers area. Then we have a blank line. And at the end, we have the body. Take a look at here. We have on the first line HTTP 1.1. That looks like a version. Then we have headers and body. Does that ring a bell? I hope it does, because it's the same pattern of structuring content. On the first line, we have the version. Here we have DOCTYPE HTML, which means we're using HTML5, the latest version of HTML. And on the left, we have HTTP 1.1, which means we're using this version of HTTP standard for our messages. On the HTML, we had two sections, the head for the metadata, information about our page, and the body part, which holds the content of our web page. And we have the same patterns in HTTP messages. We have the body, which holds the data in this message, and we have the headers, which has the metadata, the information about the data that is inside the body. For example, we have the content type mentioned as text HTML, and we see that the body holds HTML text. Take a look at the header section. We have the information here structured using label value format. Very simple, like this. Even though this HTTP message looks different from this HTML file, the fundamental idea behind its creation is the same. Very well, let's focus back on HTTP messages. As I've mentioned, we have two types of messages. One is the request and the other is the response. The only difference between request and response messages is in their start line. Let's take a look at the start line in HTTP request first. Here's the start line of the request message. As we have discussed, an HTTP request message is making a request about a resource. Here, for example, we're making a request about index.html file that is on the server. The start line of a request message has three parts: the method, the path, and the HTTP version. First is the method, which describes what kind of action we are requesting to be performed on that resource. Next, we have the path, which is the path to the resource that we are requesting for. We will learn more about path in the future videos. And lastly, we have the HTTP version, which describes this request message is following which version of HTTP standard. Here we're following version 1.1. Let's see a few examples. In this message, we are requesting to get a resource. That resource path leads to cat.jpg, which is an image file, and the version of the standard that we are using for this message is 1.1. In the next example, we are requesting again to get a resource. That resource path leads to index.html file. It's a web page, and the version of the standard that we're using for this message is HTTP 3. Very good. These were the first lines of HTTP request message. Let me show you a complete HTTP request. Here we have a complete request message. We are requesting to get a resource that leads to index.html. It's a web page. We are using the version 1.1 of HTTP standard. The next part is the header section, which has some metadata about our request. Then we have a blank line, and at the end, it comes the body. It is not required to always have a body or a header section, and you can just have a request with the first line. We're going to see some examples shortly. But for now, let's focus on the methods and see what kind of methods are available to request actions on the resources. Here are different kind of requests that you can make on a resource. Well, first one that we have seen is a GET request to get that resource. We have post request to creating or posting a new resource. For example, when you're chatting in a chat room, you're posting new chat messages to that chat room. So each time you send a new message, you're going to post that message to that chat room and create a new resource. That resource is a message on that chat room. Then we have put method, which is used for creating or replacing a resource. For example, when you're setting your profile photo, you're putting a new image as your profile on the server. And that's the use case of put. We have patch to partially update the resource. Maybe you want to edit the message that you have sent in the chat room. That's one use case for this method. We have delete to delete a resource. You can request to delete a message, for example. We have the head method, which is same as get, but it only gives you back the headers and not the body in the response. And finally, we have the options to ask the server what kind of these methods above are available on a resource. Let's see some examples. Here you're requesting to get the resource, and that resource is the photo of Kian, which is a user of this website, and the host name for that website is this. That is the header part. It's an example of the get method. In the next example, you are requesting to put, which means to create or replace, this resource, which is Kian profile photo, with this image that you provided in the body. So you want to put this image for this resource and create it or replace it. And last example is a delete request. You're requesting to delete this resource, which is the profile photo. So through the method, you're asking for different kind of actions to happen on a resource that is on the server. And that is all for request message. Let's take a look at response next. The response message start line looks like this, and it consists of 3 parts. The first part is HTTP version, same idea as the request method, describing what version of the standard we're using. Then we have the status code, which categorizes what sort of response we're receiving from the server. And then we have a human readable version, which is just a message describing the response. For the status code, we have 5 ranges of the response code that each mean something specific. Let me show you. Under HTTP, if you scroll down, you see the response status codes. And here are the 5 ranges. The responses in range 200 are successful responses, 400s are client-side errors, that means you did something wrong, and 500 range means server did something wrong. It's not your fault. These 3 are the most common, but you can read about the other 2 to learn more about them. Let's see some response message examples. In this example, we are receiving a response that is letting us know that the resource has been created. In the second example, we are getting a response in range 400. This defines client errors, that means we did something wrong, and the message is bad request. That means we did something wrong in the request that we have sent, and we need to fix it and try again. And last example, which something you've probably seen, is a 404 error. That means the resource that we're looking for does not exist. These were examples of the start line of a response message. Let me show you a full response message. In this response message, we're getting 500 error. That means there's an error on the server side. There's something wrong with the server. This is the header part, and this is the body part. As you see, we are getting text plain as the content type, and this is the message that server is returning to us. Very good. We have learned HTTP request and response messages. Now let me show you some examples involving both a request and a response message. Here we are sending a request to get the index.html from this website, and the response we get is this. We're getting a 200 response, everything is okay, and the data that's returned to us is the data of index.html. As you can see, the type is HTML. So there was an HTML file on the server computer. We have sent a request to that server, and that server sent us back that HTML file, and now we can take a look at its content on our computer. Let's ask for an image next. Here we are requesting to get this image that has this path from that server. And in return, we get this response. A 404 response, that means that resource does not exist. Alright, so there is no profile photo for Kian on the server. Let's actually send the profile photo to the server. So next, we are going to send a put request. We're going to request to create or replace this resource with this image that we are sending. As you can see, the content type is JPEG, and the image, because it's not a text file, its content are not going to be readable, but it's just the data of your image. And here's the response on the server. The response is 201. That means it has been created. It was successful because it's in the range 200. And we are seeing the message that the profile photo has been uploaded. So we had a profile photo on this computer, and using the put request, we have sent that profile photo to the server. And now the server has that image also. Next, let's send a get request to get that photo again from the server and make sure it has been set and we're not getting a 404 error. So we are sending a get request to get that photo from the server. That photo is available on the server. We have put it there in our previous request, and the response this time is 200, and it's sending us back the data of that image, and its type is image JPG. By now you have seen how using HTTP, by sending requests, we can interact with different sort of resources that are available on the server computer, and the server is going to send us responses to tell us the result of our request. Now let's go and send some HTTP requests to different servers and see what responses do we get. Let's see HTTP in action. First, I'm going to show you bare bone how HTTP works. And then we're going to use an online tool to send and receive our HTTP requests. Let's get into it. I'm inside VS Code. I'm going to open a new terminal. I don't need this tab on the left, and that's all we need. Here's what we need to do. First, we need to establish a connection to the server computer. This is called creating a channel. A channel looks like a pipe between client and server where you can send your messages into. Once we have that channel, we're going to send our request and receive our response from this channel. Let's see it. Let's send a request to google.com. Let me go find the IP address of the computer that I need to connect to. So just search for google.com, get its IP. That's the IP address that I need to connect to. Let's go back here. I'm going to use this command. NC stands for Netcat. It's just a tool that helps me to create that channel for sending HTTP messages. This is the address of the computer that I want to connect to. This is the IP address, and this is the port number. For now, don't worry about the port. We're going to see that in the next lesson. But let's connect. Believe it or not, by just typing this, I have established a channel to the server computer that is hosting google.com. Now I can send my HTTP request through this channel and get the response back. Let's request for the main page of google.com for its index.html page. I need to send a GET request. The resource that I want is index.html, and the version of HTTP that I would like to use is HTTP/1.1. Press enter. I don't have any other information to enter, so I just press enter again. And this is the response. Let me scroll up. Here you see that was my request. My request only had the start line, and this is the response that I'm getting back. This is the version of the response. They're using HTTP 1.1 as well. The status code is 200, and the message is okay. This part is the headers, the metadata about this response, and then after that, we have the body. And you see there's a blank line between the body and the header area. In the header, we have some useful information like content type that is going to appear in the body is of type text HTML. So we are receiving back HTML content. In the body section, you see the beginning of an HTML file. You see the doctype HTML, then you have the HTML tag. Inside that, you have the head tag. The first tag is meta with charset UTF-8 and things that you're familiar of. So I have established a channel using this line. Then I have sent my request. That was my request line. And then I received a response, which has the first line, the headers, and the body area. All right, let's continue and send another message. This time I'm going to send the same message again, but I'm going to use a different method. I'm going to use the head method. So head, I'm still going to get the same resource, index.html, and HTTP version is the same, 1.1. The head difference between the get method was that the head will only return the headers area and not the body section. The body section has a lot of these data that we're not interested in. We just want to see the headers related to index.html. Let me send it over. You see that this time I received a response 200 OK, and the server just sent me the header part and it didn't send me the body part. Let's use another method and see what server will return to us. Let's use a post method. So post /index.html, and the version is HTTP /1.1. Let's see what will server return. You see that I'm getting a response with a status 411. So 400 range was client-side errors. That means I made some mistake in typing this request. And the error is that length is required. Underneath, in the body section, you see some text describing your error. It suggests that that's an error, and it is asking you to include content length in your header. All right, let's do it again. I'm going to write the same request, but this time I'm going to provide that header. That header was content length, and let's set it to maybe 0. Let's see what happens. This time I'm getting a 405 error. The method not allowed. It is letting me know in the body section that the request method post is inappropriate for this URL. So it is telling me the post method is not available on this resource. Let's take a look at the options. The options method would return to us what kind of methods are available to be performed on this resource. Let me add some space. So the method name is options. The resource is index.html, and the version is HTTP 1.1. Let's run it. I'm again getting the same error that the method is not allowed, and it is letting me know that option also is not available on this URL. So that server has been configured so that it doesn't allow options method to be performed on this resource. Very good. Let me close the connection. What I want you to notice is HTTP is not mysterious at all. I will write a request requesting for a specific resource with a specific method on it, and the server sends me a response back with a specific format. It has a start line, the header area, then the body area. For the last example here, let me connect to a different server this time. I want to connect to the server example.com. I have a question for you. Can I find and connect to a computer that has this name instead of providing its IP address directly? And the answer is yes. That's the rule of DNS server. My computer now is going to communicate with DNS server to figure out the IP address related to example.com, and then it's going to connect to it. So let's press enter. I am connected. Let's go to the browser and see the example.com. On the top, if you go to example.com, you're going to see this page. We're going to send an HTTP request here to get this page from that server. So let's open a channel. Now let's write our HTTP request. I need to send a GET request. I want to get a slash, the root of the website. We're going to learn about that shortly. And then HTTP version is 1.1. We're going to learn about path and why this means the root of the website in the future videos. For now, let's focus on the response. We're getting a 400 response, which means bad request. That means we did something wrong in this request. And that error is coming from Cloudflare. Based on my experience, I know what this error is about. The server requires that I set the host header on my request. I need to provide a host header and set its value to this domain name. So let's send the request again. This time I'm going to add a host header with this value. So let's see, same request. Now a host header, example.com, and that is what I'm going to send. This time I got a 200 response. That means everything is okay. And this is the information that server has sent me. On your browser window, if you right click and click on view page source, you're going to see that HTML content that the server has sent you. Let me zoom in. You see that this is exactly this that we have got by typing the request manually. So your browser is doing this behind the scene and you're not going to notice it. You're just going to type example.com and the browser is going to do all that and show you the HTML page rendered on your screen. I hope by seeing these examples, you realize how simple HTTP is. Next, we're going to use an online tool to send these requests and see the responses so that you can practice it too. You may not have NC command on your computer installed or may not be comfortable using the terminal yet. That's all right. Here we have an online tool. It's called reqbin or requestbin. It's reqbin.com if you want to search for it. And this website allows you to send HTTP requests and see the response in the raw format. As an example, let's send a GET request to example.com and see the result. So I'm just going to copy that domain, paste it here. Here you can choose the method that you want. I'm going to choose GET and then send it. Here, if you go on the raw tab, you see the raw HTTP request that has been sent. As you can see, the host has been set along with some other headers. So that's the equivalent of us typing this directly in the terminal. Then at the bottom, you see the response. Let me click on raw. We see the response with the status code 200, which is okay. Then we have the header area with some key values. And finally, we have the body section, which holds the same text as we have seen in our browser. The other tabs has just parsed this raw request and put it in a more readable format for you. For example, if you go to the headers, you see a table with the header key and value. So that's the label, that's the value. If you go to the raw, you see that written here. So this is just a better formatting of the same information. And in the body, you see the content of the body being formatted more easily for you to read. Here you can even preview that result on this section, which is the same thing that we got here. All right, let's see another request. This time let's send options to see what options are available on this request. Let's send it. And this is the result that we got. A 405 error, that means that method is not allowed on this resource. Very good. Next, let's try to get a 404 error and see how it looks like. So let's use a different domain, maybe google.com. I know on Google, definitely a resource like this doesn't exist. So let me run it. I see that I'm getting a 404 error. Let's copy this and let's send a GET request to this address. So make it a GET request and send. And this is the response that you see. If you go on the body, you can even preview this and see that it's the same thing. Very well. I hope I was able to demystify the HTTP technology and show you how request and response work in a very simple way. I recommend you to go to this website, try to send different HTTP requests and response, and take a look at the raw outputs. This website also has some samples, the ones that you see on the left, and these are interesting, and I recommend you to give them a try. In the next lesson, we're going to go back to example 1.html with this simple web page that we started with, and then talk about this, how to run your website locally, and what does this address mean. We're going to talk about port numbers and this IP address that you see here. What you really just did, that wasn't learning HTML. You spent the last hour learning to think structurally about information. HTML was the case study. That same way of thinking will hold up everywhere. APIs, databases, config files, anything you'll ever touch as a developer. If you want to keep going, my full HTML and web course picks up where this video ends. We'll learn about URLs, paths, forms, and many more to build the full picture of what web actually is and where you fit in. If something in this video clicked for you, drop it in the comments. I read every one of it, and engagement is what helps a small channel like mine to grow. And tell me what you want me to cover next. And finally, subscribe if you want more videos like this. Stop memorizing, start understanding. That's how you stop following AI and start directing it. See you in the next one.